I guess I'll say next slide whenever you're ready, whenever I'm ready.
Sounds good. Recording has started, sir.
Thank you. For today's session, well, welcome everyone. My name is Diego Colon. I'm pretty sure you guys, I think you saw me in the beginning of this actual course. And we're going to be reviewing for today, Introduction to Networking. As some of us may already know, a computer network is a group of computer systems and other hardware devices that are basically linked together to be able to facilitate the communication or the exchange of information. Usually back in the days in the 80s, we used to call this sneaker net because there was no such thing as networking. So you need to go and get yourself a nice little floppy disk. For those that don't know what that is the little save icon. Everybody knows what a little save icon is. That's your floppy disk. You used to go and save everything to this little guy and run around the office and give the actual file to the next person. Obviously, with modern technologies and with the birth of Windows 3.1.1 and other operating systems, these features, what we call network links, have made it capable to be able to interconnect with these computers with ease. Obviously, there's various types of computer cables that are able to connect. There's fiber optic, there's actual copper, and obviously there is even radio frequency. Overall, we're going to learn today, go ahead, next slide, the details about networks, the different types of networks and how devices can communicate via these actual cables and connectors. By the end of the session, our ultimate goal is to be able to define what a network is, give the examples of a given network, identify the devices that are being used within the network, and identify the types of network cables and connectors and tools that pertain to each of this. Because obviously, depending on what we're talking about, each one has its own tools. And they're going to test you on these things where they throw curveballs and they might mention a type of cable, but then at the same time, they're talking about something else. We have to be very careful. We need to understand exactly what these things are. How can I tell? Well, basically by the category that usually those things will help us out. The networks are categorized by technology, usually by the size or the actual geographical location. You have your PANs, you have your MANs, you have your LANs, you have your WANs. Your PANs are your personal area network. It even says it in its name, personal, mine. What can I think about that? If anyone can think of anything that you personally connect to, what type of radio frequency do you use to personally connect to your car?
Bluetooth.
There you go. Look at that. So if we could always think about these words I'm about to give you and always put what you want to call the geographical circle. If it's in arm's length, humor me, obviously, Bluetooth is sometimes a little bit farther than arm's length. But if we're talking about being able to just be ad hoc, where I'm directly connecting to it and it's directly connecting to me without anything else, that is called the personal area network. That means it's me. I'm in control and it's my area here. Something very close to that, and a lot of people have issues with it, is the LAN, because of the fact that there is some devices that can live in both PAN and LAN, depending obviously on how you actually interconnect them or how you're actually using them. Your local area network is that itself, it's the actual facility itself and the subnet that's inside this building, usually interconnected with switches, hubs, and or maybe some type of wireless access points. You have obviously your wireless LAN, which is all inclusive of what is a wireless local area network. Your MAN, which is your metropolitan area network. We'll get into the details of each of these. You have your WAN, which is your wide area network, or some people like to also, since they know it's part of it, it's also where the internet lives. With these in these things, there are different type of network types and topologies. You have your mesh, your ring, your bus, your star, and your hybrid. I could only pray that you guys read, because if not, I am about to be speaking German for the rest of this whole dissertation and or Nearpod session. The devices that we're going to be using in here are in reference to our hubs, which is our dumbest one, including the NIC card that's in the back of the computer. You got your switch, you have your router, gateway, firewalls. The cables that we're going to be using and connecting these, as we stated, are the coaxial, your coaxial single RG59 or RG6, whatever you want to call that cable. You have your twisted pairs and you have your fiber optics. You have your required tools that we should be able to identify with ease, and that is your crimper, your punch down, your multimeter, cable tester, and your toner probe and loopback plug. Go ahead and next slide, please. Overall, what we need from all this blabbering I got, adaptability and growth mindset. If we're not able to adapt to the given situation in the network, we're going to sink real fast. Growth mindset is a must because of the fact that all this technology continues to change and grow. Therefore, we should hopefully be prepared to learn in reference to all the technologies and all the new technologies that can continue to come out. Just alone inside your actual wireless technology, it itself went from A, B, G, and AC, and I don't know, LMNOP, God only knows how many letters they've thrown into these things. As you can see, just by the years going by, each one changes. Even the category of cable when it comes to the twisted pair. Next slide, please. Overall, as I said, what is a network? Help me out here, Jackie.
A network is, it provides you connection to your,
It's there. It's not a trick question. It's on the slide.
okay, connection, communication, and services. A network links computers for communicating and sharing information and resources.
Excellent. Thank you, Jackie. So that's the main purpose of a network when you're establishing it, is just predominantly for the facilitation of that communication and sharing resources between each and every computer or server or whatever you have attached to that particular network.
Thank you. Sorry about that. Go ahead into the next slide. So we must be able to understand what it actually provides, and it provides in these different levels. We need to understand and identify these things. We have our clients, we have our servers, we have our network devices, and we have our medias. William, so if you could help me out here with these different definitions of the components that create the actual network.
Yes, these are the network components. Client, device, client, the device the end user used to access the network. Examples are PC, laptops, smartphones. The server, what it uses is the device that serves up resources to a network. Examples are email, web, file, proxies. Network devices create the network. The examples are switches, routers, access points, and media. Via to internet connect devices. It could be wired or wireless. Examples are copper cable, fiber optic, and Wi-Fi.
Can somebody tell me who is PDDA? Who is PDDA? Physical, data link, internet, transport, application layers. This is where we need to understand when it comes to the network components. When we're troubleshooting software or we're troubleshooting computers, they've been telling us to always start with the least intrusive, which is usually an application. We all agree? I wouldn't take the computer apart. That's not the least intrusive. Do we agree on that so far? Because it's going to get real hot and toasty real quick. Now that we agree on a software, on a computer, if I'm troubleshooting, they tell me to troubleshoot the least intrusive first. Is that a true statement?
True.
Yes.
Okay. And when we're talking about computers, go ahead. I'm sorry, Jackie, you have a question?
Yes, what did you say the PETA was again?
That will be your physical,
Data
your
link,
data link, your internet,
internet,
your
okay,
transport,
transport,
and then
and
your
a-
application.
application. Okay, thank you.
TCP/IP model that they use in Coursera.
That's the 5 model, the 5 layers or 5 flavors, which is the easiest one out of all of them. Because then there's the one with the 7 layers of flavors, and God only knows why they came up with it. just to torture us, that's all. But either which way, the easiest one is PDTA when it comes to troubleshooting itself. It saves you so much time you cannot imagine. Why? Because like I said, when it comes, this is the most confusing part. When it comes to a computer, the least intrusive thing is me working with the mouse and the keyboard. That is the least intrusive thing. If I take the computer apart, that is the most intrusive thing because now I'm going inside of it. That is a computer. Now the network, my friends, they play the game completely backwards. The least intrusive is the physical layer. This is why they're trying to make sure we understand what a client is, what a server is, what a network device, and what is a media. Depending on where we are in the network, these things all fit into those little locations. Our client is the person that you would consider inside your Starbucks ordering up the coffee. Your server is the person that's right behind that counter and is serving the coffee. Your network devices is the actual beautiful, whatever you want to call it, espresso machine, and the media would be the cup that they're delivering it in. I know. It looks like I work in Starbucks. I don't know. Either which way, we need to be able to determine where it is, because I said the least intrusive is the other way around. So physical layer, my network cable, my network card, my hub, because he's that stupid. He's actually on the physical layer. The power of these devices. These are the things that we need to be able to look at first before I go anywhere else. Because if the first layer is down, it is the least intrusive thing that I need to check first. Next, I can check is the data link. What is the data link? What else are your actual network devices when it comes to, in play in this case, is your switches, right? Your MAC address. It's all speaking in MAC. We're going to get into the details. I believe it's going to show us a little way how he packs up Humpty Dumpty. But I just want to make sure we understand these different things and how they are in the network. So the first three are actual devices that are out, are live, and have components that you can consider as a humongous computer or some sort of equipment. And the last one is the physical cable, the media, being that it is a wireless antenna, be that it is fiber optics, copper, coaxial. If I can touch it and there is a signal being radio, electricity, or light, that is the media. That's the way it gets transported. The ones that make it happen, those are your network devices. Those are the ones that are smart enough to figure it out. Now, some of them are very stupid. Your hub is as dumb as a doornail. That guy just pretty much screams out to everybody. So Jeremy wants to talk to Kelly. Guess what he does? He goes, Kelly! Now, as for a switch, Jeremy wants to talk to Kelly. He goes, hey, Kelly, what's up? How you doing? Man, yeah. He keeps it private. A hub, he can care less. He lets everybody know. Oh, by the way, Kelly wanted to see the XXX site on this location. Oh, you're not Kelly? I'm so sorry. Disregard. Don't worry. That's got nothing to do with you. So we need to be able to understand those two are your first, what we call data link areas. You have your hub, you have your switch, you have your bridge. And we'll get into those as they come. Any questions on this slide?
Yeah, I have a question, sir.
Mhm.
It's you just mentioned that on a data link there are the device just like a switch. What about where can we put a hub actually? It should be in a physical layer or in a data
Hub,
link?
hub is a physical layer. That is correct.
What,
It
what,
doesn't know what a MAC address is. It has no idea anything.
okay.
A switch knows what a MAC address is. So what happens is as soon as you turn on your computer, it has a table. So when he turns on, he goes, hey, I need an IP address. And then the switch automatically, as soon as he grabs that packet, he grabs your MAC address and he puts it on a table. He says, all right, this guy's here on this port. Now, Kelly comes later on throughout the day and says, hey, I need to talk to Moog's computer. Instead of going and searching or calling it out to the world, he automatically just connects them straight to that port without having to figure out where you are connected. Because as soon as you connected, you ask for an IP, or you might have started any conversation, and that actual initial packet contains your MAC address, and it writes it down to a table so it can figure it out without having to tell everybody that he's looking for you. Now, a hub can care less. He tells it to everyone on the port. He just keeps on bleeding it to everyone. A bridge does exactly that. He bridges from one to another, not to be confused with a repeater. A bridge will bridge you from fiber optic to Ethernet. A bridge will bridge you from token ring. No, that's wrong. From coaxial to twisted pair. In other words, it bridges you from one type, physical type, to another. The repeater just repeats. He just keeps on repeating the signal. You guys probably know them very well as Wi-Fi extenders. I'm sorry?
No, I was just saying it repeats the signal over the same medium.
Exactly. It's the same type of medium. So if it's a Wi-Fi extender or a Wi-Fi repeater, it's the same thing. If you have a repeater that's for an Ethernet copper connection, then it will repeat. It's because of the fact that the distance is so degraded. The distance is degrading the signal that you require for something to repeat and obviously add energy to the line, be electricity, or if it's a radio signal, or if it's fiber, depending what it is. He just repeats the existing signal. Yeah. Next slide. Ooh, beautiful. You have your mesh, you have your net ring, you have your bus, you have your star, and you have your hybrids. As for, where's my little pen? I don't have a pen. That's not fair. I don't got a pen.
What do you need?
And I need to annotate, be able to annotate.
You should be able
Don't
to
mind.
off the shared screen.
Yeah. Apparently, I don't remember how to do it.
Okay, we will provide IT support for you.
I know how to do this. Look, hey, okay. Either which way. As for the mesh, a mesh is basically a topology where every single node has a connection to another node. What do I mean by that? So if we had 3 people that are connecting to each other, there would be, in essence, a connection that not only goes from me to Kelly, but there would be a connection from me to Jeremy. At the same time, Jeremy and me would have a connection to Kelly. Right there, you'll see that right there is a star. And now to be able to create the mesh, all of the circles must have a connection to themselves. And that will create a mesh. So the first one that you saw there was basically a star where it starts from a centralized location and it all spokes out. In a mesh, every single one has a basic connection back to any of the other ones. Why is this, you may ask? Well, it's a very, very expensive way to ensure that the network does not go down. You see this a lot when it comes to your internet connections. Your internet service provider has a mesh network, which if one of these nodes happens to go down, only that router go down, only that facility loses network connectivity, but the actual packet will bounce to another router who's able to continue the call for you. That's the essence of the mesh network, is for the ultimate redundancy of a network and to ensure that every connection has its own redundancy to another one. Now, they might ask you, I'm not sure they do that in this test, I haven't seen it yet, but they'll ask you how many is the lines of communications, my friends. And that, if I remember correct, is N, what was it? N times N minus 1 divided by 2. In other words, if you look at this, there was 3. So 3 times 2 equals, sorry, 3. Yeah, 3 times 2 equals 6. Divided by 2, there should be 3 lines. Did that make sense? You see the 3 lines, one going from here and the other one going from over there, and one over there. So if at any point they tell you 5 routers, now you know it's 5 times 4 is 20, divided by 2 is 10 lines of communication. 10 ways that they are redundant to each other. Questions on the mesh?
Yes, Ashley.
Yes.
Wouldn't it just be easier to multiply by 2 instead of having
Multiplying what by 2
Okay.
so I can understand?
for
Now-
the
How about let's, okay, so let's try
It
this.
all
with-
changes depending on the amount of nodes. So if we
Yeah,
create
okay.
four nodes, if we put 4 nodes in there, you'll see that it's 4 on the end. And then N minus 1 becomes 3.
okay, I get it now. I'm
So that-
sorry.
All right.
So
So then that
4
becomes,
times
and then
3.
that becomes
Divided by 2.
12, and
Yeah.
it becomes 6.
So
Okay.
I'm
Yep.
sorry. I have a question here. Why we divide it by 2? Why don't we
That-
divide it
That's
by?
a mathematical equation that some person out in God only knows where created to be able to get to there. But it will get you to the right amount. The reason you're dividing by 2 is because of the fact that it is calculating the number of lines of communication, the amount of redundancy lines all around. And that's the way they came up with the formula that gets you there. Any other questions?
Question. So is a node just a router? Or does that include hubs and switches and
So
stuff?
the
too?
node, sorry, the node would be the actual computer itself.
It could be a computer. It could be anything that's on the network.
Yeah, computer,
A node.
server, phone.
So now, for instance, in a ring topology, you're gonna have a node which basically is throwing the ring around the rosy. So if you don't mind throwing that little circle. What happens is that each node is responsible of talking at a given time on a ring network. Usually you'll see this a lot in what they call the token ring. This basically happens is that I can talk when I have the token, just like Lord and the Flies. Anybody remember the conch from Lord and the Flies? Nobody? Anybody remember the conch from Lord of the Flies? Nobody saw Lord of the Flies? Oh,
Yes.
man, you guys. Man, you have not been tortured well enough. I'm telling you, man.
Is that like Lord of the Rings?
No, not but
It is so much so much
It's
darker.
one of those it's like the Great Gatsby or one of those books where they make you read usually in school. Don't worry about it. It's just me. I always like to go into tangents, see if I can make it easier. All right. So basically, no one can talk unless if they have the token. So basically, every single person gets a chance, and it usually starts rotating in a certain direction. And for the purposes of this, we'll say that it's going counterclockwise. So it'll start with that person talking. And then as soon as he sends his byte of data, he has to release the token into the cable, because this, believe it or not, is a physical circle. It's not a virtual, this is physical. And it starts going around, each person adding their information and sending it until it gets to the actual switch, which the switch may be somewhere in the middle of this. That is a ring topology. If any break happens in the ring, the whole network is down. If any of that bus goes down, your whole network goes down. So we just went from mesh, which was the ultimate of all redundancies, to something that has a single point of failure. Questions?
To be fair, the star also has a single point of failure, but the failure is the center of the star. It's either the switch or the hub.
Agreed. Agreed. Next is our bus. Any question on the ring? These are physical topologies, not to be confused with the logical topologies that we're about to talk about.
Is the ring have like a benefit, or is it just like legacy stuff?
It's legacy. It's it was the second one right after bus. Bus is one of the easiest ones to figure out, and that's because of the fact that the bus is that you're riding a bus. It's a single line going straight. Again, single point of failure. If there is a break in the cable anywhere, the whole thing is down. Questions or doubts? And that one's the oldest. The bus is one of the oldest. I doubt you'll find that one. But if you think about it, technically, you do still have bus segment on your network. Anyone want to chime in on that one and take a wild guess? Where is this little bus segment? What's a segment in math? Anybody? The
Load
part of the
divider.
line. Right? A segment is a small line, right? It has a definite end and a definite start. A little piece of cable. One little piece of cable that you usually connect to a computer that goes to the network.
Oh, Ethernet cable?
Thank you. You can always remember that is one of your single point of failures going into that switch, right? So if something's wrong with that cable, either in the wall or the cable that is coming up to the patch panel, all those are part of the bus. You have to be fully aware. Your network can be intertwined with each other. You could have a segment that's bus, then all of a sudden it goes onto a star, and then all of a sudden when it gets out of the building, it's in a mesh. It's all depending where you're at. Questions on the bus. So we ride the bus, and we die on the bus. If anything goes down on the bus, the whole bus is down. Physical again, we're talking about physical.
Also, on the bus, real quick, on either end of the bus, they would have to have a terminator on the end of it. Otherwise, the signal won't be reflected back.
That is correct. It is called the 50 ohm challenge. I still remember that. I feel so old. What happens is, as you stated, not only does it have to be all the way at the end, if you go to the third computer, if you don't mind, in that drawing, pretend that you're taking that third computer out. The moment that you take out that third computer, that little end connector that he's talking about, you best bet you better put that on the wall. So that little returner on the end of the cables, unfortunately, you need to make sure also that you put it there. If it's not being used, if that port, since it's one big cable going across, and then there's a point where it basically, you're coming off of that cable, right? So that point has to have the cap on. If not, the signal does not continue through the line. Or in his case, if it's at the end of the line, it reverts it right back. So it can go up and down. The signal must be able to go up and down. Questions or doubts on the bus and why it goes down? Now, the easiest way is either 50 ohms or 25 ohms. You use yourself a multimeter. You come up to that little head, which is usually a BNC connector. BNC connector is a little lockjaw one that goes like this and basically locks itself on. You still don't know what a bayonet, Nielsen, Coleman cable, or Kleeman, whatever his name is, and I would say read the book. BNC connector is very vital when it comes to these things. What was his name?
Bayonet needle
Bay-
councilman.
That guy, bayonet guy. Either which way, we need to understand that that is the place we need to go and either have 50 ohms or 25 ohms. If we see 25 ohms, we found the spot, don't move. That is where exactly the actual cable's gone bad and or the tip is not on. Same true for the actual ring topology, has the exact same thing, usually the coax cable with a BNC connector. And if that's happening, then usually you'll have the exact same way.
Both the bus and the ring are coax medium.
Questions, doubts? All right, our friend the star. Now this is seen a lot in the lands. A lot of the lands out there are in a star topology where they have a centralized device that manages the actual traffic. If you notice, I never told you anywhere in that there actually has to be a switch or a hub. When it came to the ring and the bus, at no point did I mandate that there must be a switch or a hub doing something. Obviously, it would help, obviously, if you had a switch when it came to the ring topology, but it's not a mandate. You could physically create the big circle around the whole office and there's no problem with that. Now, as we see here, in a star topology, you have the centralized node. Usually the connection goes to that main switch. So the router probably be going to that switch. And then all the computers in the office connect to the switch, who and then make sure that it sends out the signal to the correct people. This is a star network itself, and it could be a hub. Why? I did say it's stupid, but physically it's still a star because it's a hub with 24 ports. It has a centralized location where everything comes to it. Questions, doubts? Now, our last one is obviously the hybrid, and hopefully that's easier to understand. The hybrid is, in fact, that it is a hybrid of any of the ones that we just spoke about. You see this a lot, what is the star and the bus technology or any of the other ones, those are usually out there or when it comes to this technology. The star bus is very, very famous. Star ring is not being used much, but it's still available. We're talking about logical. Why? Because of the fact, instead of me just having, well, let's say that centralized switch, I could have that switch with the router and then have maybe 4 fiber switches, where then those are the ones that are feeding all of my closets. And then this guy is connecting to those main switches. And then they send themselves out. So there'll be a circle with all those switches, but to the computers is a star. There will be a ring with the switches so that they all connect with each other. But as for all the computers, it would be a star from the switch itself. It is a centralized device that's managing, but the backbone where all the switches are connected to each other, that may be a ring network to ensure that there is redundancy inside that topology. Questions?
So when you switch from in the hybrid from one type to another, you have to use another hub or switch?
They're just letting you know that the physical topology can be mixed and matched. It can be a hybrid.
I actually have like a 2-part question. I didn't have a chance to ask earlier. Going back to the star network, just based upon the information, the star network, is that only good up to 5 computers maximum, or can it go beyond?
The star, you could always imagine the star as a sun. You can't really calculate the amount of rays coming out of the sun, can you? But you could draw a picture about it. Therefore, the star topology is really It's just showing all of the ports that are coming out of the switch. Usually it's 48 or 24 things. So all those connections are coming from that central node. That device that's there is connecting everybody to it. So he's basically just like a star extending out all his connections. That's all it really means.
Oh,
Just a
okay.
physical connection. So you know what it looks like physically. It is that everybody connects to that device as a central node.
We were just using 4 or 5 for simplicity's sake.
Mhm.
All right, thank you.
So then when they talk about the actual hybrid, what they're saying is a star is a switch, we agree, right? So now if I put several switches next to each other, I can use a ring topology to connect the backbone so that each switch could talk to each other. They will be all in a what you call a ring, while all the computers are just going out like spokes. That's a star, but the backbone, the way that they communicate with each other, it would be a fiber optic link to each one, and it would be physically a circle inside the building. And that's what they mean by hybrid networks. West, south. Continue the next slide. Kelly? Thanks. Here we are. So here's our little pictures, which helps us look at it a little bit better. You have the first one there, which is your mesh network. As you see, every single computer has a connection to itself. This is very costly to try to do. Could you imagine this inside a building to do this? It doesn't make sense. For the internet, it's perfect sense because now every single router has a connection to the other router so that if one of them goes down, everybody else can still talk. We understand, yeah, that site is down, but everybody else can talk to each other. And that's where we get the, again, that n minus n minus 1. There is 6 nodes in this picture. So 6 times 6 minus 1 is 30, or 6 times 5. And when you divide it by 2, there should be 15 lines. If you feel like counting it, there is 15 lines. Any questions on a mesh and what it looks like? It's the physical topology. Next one down is the common bus. As we see, the line right through the middle is the bus. And then, as you saw, I was in line, they tap into the line. So right where you see that little line that's coming out in that diagram, that's what they're representing. All these things, we should be able to recognize these diagrams as what they are. So if they give us a picture like this again, we should hopefully understand what a mesh is, what a bus is, what a star is, and what a ring. Any questions on the bus? Now we see here on the right upper, the star network itself, topology. If you'll notice, there's the switch in the middle. There is a device in the middle. You see how the device is even printed there so that we're fully aware it must contain a central node where everything connects to. None of the other ones say that there is a central node. At any point, is there a must to have a switch or anything in the middle? It's nice to have, but it's not a must. Questions? All right, continue on.
Next slide.
Yes, please. Next slide. Sorry about that. All right. Going back to the definition of client server, as we said, in a client server network, these are words that we need to understand instead of a peer-to-peer, which we're going to get to, I think, sooner or later. Client server means that there is somebody there. If you're in a buffet there's usually nobody serving you. You're serving your darn self. That would be a peer-to-peer. But in a client server, there is a master computer providing services, be a web server, print server, file server, proxy server, server. I don't know. You get my point. They all end in server, right? Either which way, you are the client. Always the PC is the one that's going to be asking for stuff. Obviously, there's some PCs that you use as server, but in essence, let's just try to stick into simple terms. We need to understand who's the client and who's the server. And these types of network obviously contain those type of situations. And the server always provides authentication. That's one key thing to understand. Go ahead and next slide. Ooh, here we go, peer-to-peer. This guy has no servers, absolutely nothing. If you have a print server on your network, you got a client server network. Oh, but Diego, that's the only server. Well, no, that's not my fault. That's the only server you got. What do you want from me? Either which way, in this case, nobody is the boss here. Nobody is serving the coffee. Everybody's getting their own coffee. Everybody's serving their own food. Worst thing about it, it is a nightmare when it comes to us because of the fact that every single computer has to have a way to connect to each other and an ID and password when it comes to Windows or any other ones. What do I mean by that? Since you're no longer going to a server who's authenticating for you, now every single PC must have whatever ID that you need to get into it. So if there's 10 employees, that is 100 IDs and passwords that you gotta place. Why, Diego? Because you decided to have a peer-to-peer. There's no server. So every single computer must know what's the ID and what's the password. And I'm only praying that you guys are not sharing IDs and passwords, because in that case, if you are sharing, there's only one ID and one password, and then you could have 500 computers and you really don't care. In that case, I don't even know what we're doing. But either which way, the right way would be a headache. After 10 computers, ultimately, a peer-to-peer is not going to work because of the time it takes, and a lot of these operating systems won't even let you do it. Now, next slide, please, if there's no question. Here goes our friend Pan, which one of us was able to help me out earlier. As I said, this is the stuff that we understand that are near us and dear to us. My head right here, my other laptop. When you said, oh, no way, why? Well, yeah. Haven't you also done it with your iPad? Has anybody ever done AirDrop? AirDrop is a pan. That's not going over any LAN. That's basically you to it. Anything that's a short range communication, firewire, USB cable, even directly connecting one cable, one computer to another. If you're not using a network and you're using a crossover cable, technically that's a pan. You're just using the resources between you and that device itself. And you're saying, well, wait a minute, but there's a printer here. How in the world if everybody prints? Once again, I'm pretty sure you do it at home. You have that way of Wi-Fi direct, or that printer's little thing that says that you connect directly to the printer and you're not going over your Wi-Fi. That would again be a personal area network. As long as you're not using something else in the middle to be able to relay the message, it is a PAN. Does that make sense? As long as nothing else is in the middle doing the communication for you. There's media, but there's no node per se, or a device that's there, like a router or switch or an access point. Someone had a question.
Scott, did you have a question? No? Okay.
Okay, no questions. Then I guess we can go on to next 5. Our local area network. Local area network is that. It is local. We always have to think about this, although this is very difficult for some people, because as soon as they walk into one of these humongous facilities, they can't understand how in the world Diego said that this is a local area network. Hence, if you're in a college And there's 50 million different facilities in that little area. What do I mean by that? I'm pretty sure some of you hopefully walked into a college. There's more than one building, but it is one land. It is confined in a geographical area and is considered the same land, obviously, if it's in the same network and it's inside the same subnet. But physically, the most important part is the geographic confinements of this. Not to be confused with virtual lands, which I'm not getting into detail. We're talking about physical topology. It is local area network is a given confined area. Wouldn't be much more than that actual university. Now that university has a campus in downtown, and this one here, that would be an extended center. It's not a land. It might be a man or it may be a WAN, but it's not going to be a LAN. Making sense? Hopefully. Within your LAN, you'll have the different types of physical topologies. I said before, you have your bus, you have your star, and you have your ring. I said bus earlier, and hopefully we all remember. So whenever you say, wait, there's no way, how can I have it? Well, just the demarcation from the actual telco to the router, that's a bus connection. From the router going to the switch, that cable is a bus connection. Only one connection, right? If it's a straight cable, nothing else. Make sense? Next slide, please. WLAN or wireless LAN. Your wireless LAN is exactly that exact same thing as a LAN, but God only knows. Somebody went in and debated the fact that it is not a LAN, so now they came up with the word wireless LAN. Again, geographically confined to a given area. It has to be in this given area. If I'm going over the WAN, it's no longer a LAN segment. This is usually obviously to be able to facilitate in those facilities. A lot of the hospitals nowadays, all they have is just wireless LAN because they just don't have capabilities of having LAN in all areas. No difference from LAN. The only difference is the media. Does anybody remember what a media is?
Fiber optics, Wi-Fi,
Thank you.
coaxial.
That is correct. Fiber optic, coaxial, twisted pair, Wi-Fi. That is the media. So the only difference in here is the actual media in the connection. It's the exact same thing as a LAN. Only thing is the media. Thank you. Next slide, please. Oh, geez. All right. So, like I said, in those hospitals and in these big campuses, you could just imagine the cost just to be able to put these things up in fiber optics. Or I've seen this a lot when it comes to actual places when it is like in the airport. So you have this humongous tarmac where the actual airplane needs to be fitting in between. But then there's people scanning out there. How can I, if it's after so many feet, if anybody remember, well, I don't know if you guys got into that part yet, but there's just so much range that the wireless antenna is going to give you. Even if you have omnidirectional or if you have directional antenna, it doesn't matter. There's just so much. So they've created what they call the wireless mesh network. There is no copper, except for one would have a copper back to the router or to the switch, depending on which way this is being set up. Then all of the actual antennas, they create a wireless mesh with each other to be able to be redundant with each other so that if one of them goes down, the other one takes up the call. Any questions or doubts on a wireless mesh? This is still a type of LAN per se. Okay, all right, next slide. Our mans. This is the one that really kills people because of the fact they can't figure out between the man and the WAN or the LAN. The man is in the middle. The man will be obviously most likely 99% chance that it is some type of government branch or something like, again, the university that I just said. So the university is just confined, or the college is confined by maybe in this campus, but then maybe 5 blocks away is another location. Instead of me paying for a WAN connection, I can actually pay for a MAN connection, which is obviously much cheaper, and it covers the actual area. It can cover a whole metropolitan area, city, or just a few blocks. You decide how it is you want the actual connection. Very close to being a WAN. The only difference here is the geographic confinement. It must be in a metropolitan area or smaller, and bigger than a coconut. Sorry, bigger than a land. Questions?
Just one. I noticed where you said that you could pay for man, which I thought was interesting. But you said it depends on the city. So, for example, would we be able to pay for it here, like in Broward? Oh, well, I don't know where you're from. I'm in Florida, but like Broward Boulevard, Broward County, does it matter?
Yeah. The Broward Sheriff's Office use a man, so you can get adjusted
That
it.
part.
So the Broward Sheriff's County uses a man with all their facilities, and then they'll use a WAN with, let's say, FBI. So their man would be all of their facilities inside Broward, including the cop cars that are out there. That would be their man network. They can have it part of their wireless network out there, right? So that encompasses that given metropolitan area. It could be also the fire department. Some of these ambulances too, or hospitals have mans. It's basically interconnecting several LANs together. That's the key thing we need to understand. The variance between a LAN and a man is that a man puts several LANs together, and it's confined into a metropolitan area. Questions or concerns? And now moving further away is our WAN. This one should hopefully be the easiest thing. If it's outside, it's going to interconnect several LANs or MANs. So it can do both. It can interconnect LANs, MANs, and other WANs together. Inside here, obviously, this means that it is geographically not confined to a given area. This would be a global connection, or maybe state to state, or maybe a city to another city. That would require a WAN, a wide area connection. A lot of people know this as the internet, but there is a thing called the intranet. The only difference is, just like in your highways, the internet I-95 goes from one state to the other, while the intra-state highway 826 only stays inside the state. In this case, intra with an A, net would be an internal internet. It's an internal type of internet. It is a private internet connection.
The DoD as an intranet.
Intranet with an A.
Yep.
So WAN connections can take you directly to the public internet, or it can be taking you to a private intranet, which would take you to the company's private network. It's a collection of LANs together. Questions or doubts on a WAN?
It's an extremely large network. It could span the entire globe for a WAN.
Matter of fact, we have a WAN right now connection to Mars, as an example. Slow as hell, but we have it.
It only takes 20 minutes to get a response.
Yeah, more or less. All right, next one. All right, now our NIC card. I alluded to this guy earlier. NIC card is usually in the back of these devices. Obviously, everybody's got a NIC card or a WIC card or something. And basically, it is there to be able to create the actual signaling across the media itself to be able to communicate with the external. It could be Ethernet, it could be token, it could be fiber optic. It all depends on the NIC card that you have. The NIC card and the WIC card are almost the exact same thing. The variance is a NIC card is your network interface card to connect you to a local area network, and your WIC card is your WAN interface card, which gets you to the internet or intranet, usually found on routers. Questions on a NIC card job and what it does? We need to be fully understanding this. So everything that's coming out from this computers is going to be broken into little pieces of electricity. Depending on its voltage that it's sending out, it'll send a 0 or a 1. Next. Ooh, MAC addresses. See, I alluded to this guy, and that will be your data link area earlier. So we need to understand that you can consider your MAC address being your social security number, while your IP address will be where you live, for instance. It could be either your work address, it could be your home address, it could be your mom's address, it could be wherever you're at. Well, your social security is your social security. It doesn't matter where you are, right? That's where MAC address comes into play. These manufacturers have the first 3 sets of hexadecimals assigned to the manufacturer. Oh, yeah, 3. The first 3 sets of hexadecimal are all correlate to the actual who created the card. And then the last 3 sets is the actual, what you would consider the serial number of the card. Combine them together, it creates the actual MAC address. There should be, at no time, anywhere in the world, 2 MAC addresses identical, unless if somebody went on purpose and created it. Specifically on a LAN. This is when it comes to LANs itself, because God only knows sometimes, somewhere, they're gonna run out, right? I would say they will run out, right? They just kind of can't make that many cards. There's only one code or 2 for the manufacturer, and they only have so many serial numbers. But you just got to think about it that way. Inside the LAN, what is the possibilities of it? It should be 0. Nothing should duplicate itself. Now, on the chart on the right is the actual decimal representation, what we humans are used to. And then you have the binary in the middle, which is what the computers understand. And then finally, what's written on the card is the hexadecimal. Hexadecimal is a 16-bit or 16 base, sorry, numbering system. Am I correct? Yeah, 16 base. It has 0 through F. So yeah,
Yes.
It's technically up to 15, but 0 is a number in itself, so that's 16. So hopefully, I can only pray, you guys started playing around with binary and learning it, because you've got to memorize it. It's unfortunately written in backwards. you start from right to left. Well, that all depends from what country you're from, right? Some people do read from right to left. But for us here in the United States, unfortunately, it looks to be backwards. We need to be able to identify and hopefully be able to recite the following numbers. If you're able to recite the following numbers up to the point that I am, it will get very easy when it comes to networking and anything else with these computers. The first number is the most easiest number of them all. It would be 0. The next number is 1. Then you have 2. And you have, I'm not doing the count, sorry, I'm not doing binary yet, but I'm just giving you values right now. So you got 0, you have 1, you have 2, you have 4, you have 8, you have 16, you have 32, you have 64, you have 128, 256, 512, 1024, 2048, 4096, 8192. Yes, I am doing that to torture you. My friends, here they're only giving us 4. And if we don't know that the first one on the right really represents 1, we're in trouble. The reason we get 0 is because everything is turned off. The moment that I turn the first one, it becomes 1. Now, what we're going to notice is that there is a pattern to this mayhem. It is a pattern of turning off and on. So the moment that I turn on my first bit, I have 1. Then I would actually turn off that bit and turn on the second bit. I have actually the number 2 because the second value is 2. The second placement is 2. If we look at line 2 there, you'll see that it's 0, 0, 1, 0 because of the fact that the second value is 2. The third value in this thing is 4. And then the fourth value is 8. So with those full numbers, 1, 2, 4, and 8, I can make any number I want from 0 up to 15, depending what I turn off and on. What's beautiful about this is if you remember that this is 1, this is 2, this is 4, this is 8, and this is 16. We can play with the other ones later. But what's beautiful about this is that if you turn everything on until you get to that bit, whatever this value is, if you turn them all on before you get there, it is 1 less. So there, if I turn on the first 2 bits, my third bit is 4. That means that automatically I should know that this is 3. I'll do it again. I'm going to just turn on the first 3 bits. This was 1, this is 2, this is 4, and this guy's 8. If that's 8, that means these 3 together is 7. Just shortcuts that I have for myself. Questions so far on how the numbers are being created and how to do it? Can somebody then maybe humor me and tell me how is it that I'm going to get 10? Which bits am I turning on and off? No, you can leave the chart on, but they got to tell me what are the bits. I can leave the chart there all day. Just want to make sure we understand the bits.
We're turning on. Well, I have to write it down, so I ain't gonna pretend like I know it. You can turn on the 4th one and the 2nd one.
And what do they represent? What does the 4th bit represent for me? What's its value?
8.
Okay. And then the second one, what is his value?
2.
There you go. So 8 plus 2 is 10. Questions so far on what we're doing? Alrighty then. So that is decimal to binary. And this goes on forever. Ever. I only went up to 8192, but you just double it every time. And it continues with the numbering system. So it can create any number in the world that it wants because of the fact that it could just turn off or on bits. Does that make sense?
And when you're
Everybody comfortable?
sorry, what?
I was asking, is everybody comfortable with that before we go into hexadecimal? Because you gotta understand what's going on here before we even try to translate to hexadecimal.
When you're writing the binary, if you have a chart kind of like written out like this for yourself, this one is for hexadecimal, which hexadecimal is a nibble. Does everybody remember what a nibble is?
Yes, it's half of
Half
a
a byte.
Half a byte, so 4 bits. So if you just, for quick reference, the first few times you start working with binary before you become extremely comfortable with it, write down this chart right here. And then when you get a number, say if your number is 12, you're going to start with your highest number, or 13, let's, work with that. So you start with your highest number and you got 8. So an 8 goes into 13. So there you go, 8 minus 13. That'll give us 5. We have 5 left over, right? So we don't have a 5, but we do have a 4. So check the 4. So 8 plus 4 gives us 12. We're trying to get to 13. So 13 minus 12, we have 1 left. So 2 wouldn't work. We put the 0 there. We have 1 left over. There we go. So now we have 8 plus 4. There's no 2 plus 1 gives us 13. When you get to a full byte, an 8-bit octet, you're doing the same thing, but you're going all the way out to 128. You're doubling it each time until you get to 128.
And we must know a whole byte, at least up to the byte.
Yeah,
So
the
that's
byte.
8 bits.
Yep. And when you turn on all the bits in an 8-byte octet, it gives you 255. It's actually 256, but 0 is a number. So you get 255. Are we comfortable with this so far?
I'm gonna say no. But I can get it over time.
No.
I have a question. You said 1 whole byte is what?
Is 8 bits.
8 bits.
8 bits. Okay. And then that's 255.
Yeah,
It becomes 255, that's correct.
Yeah.
Okay.
So, let me get my pen here.
If you don't mind writing all 4 of them there. Actually, bring out the, if you like the
Whiteboard.
Excel sheet. No,
Oh, you want anding?
might as well.
All right, we can get into that one. I know we're going to get into it tomorrow. Let me pull it up in 1 second.
No, just to show them at least the 256.
True, very true.
Yeah, there we go.
I'm going to go to the one. It's right here.
No, let's go back to the other one. The other one's smaller, much easier. Okay. I think I can take control. Can I take control? No.
Well, I mean, if you open up anding on yours, you can share your screen.
That'll be too easy though, man. Come on.
Yeah, you can do a remote request with me. I'll grant you access.
This is really hard when I'm not the buttons are not there anymore for me. I don't know why.
Are you not a host? You should
No.
be. Yeah.
I'm not sure why. Says that I am, but I don't have all the options in here. Oh, there it goes. You could only find it. Alrighty then. So here's our bits here, the ones that we were talking about. You have your actual the value of it versus the actual number placement of it. Our first row right here is the 8 of them, counting all 8 of them. You see it there? Or the whole byte. What the computer is going to see is this down here, this line here. It's got internal ways of calculating everything on the top, all right? So if I'm going to be sending something through the network, or if I'm writing anything to it, it basically looks at the actual information that's in here, and based on that information, I'm so sorry, give me a second.
Anyone game for a study group after this?
I am.
I am.
I am.
Yeah, definitely.
This is gonna be the building block for everything that comes after. And tomorrow's TCP/IP.
So, Mr. Kelly, when
Yes.
these lines are started, like this one, the third one says 128, are the
Mhm.
other lines adding up to be that? Are they taking those numbers to calculate the 128?
Yes, well, here's what's happening is it's a base, everything in binary is base 2. So for every bit you add, you're doubling the previous one.
Okay,
So the first one is 0.
All right, where did I
If
put
you
my
turn it
ear?
on, it would be 1. The
okay,
next one, you would double it again, and then you would get 2. And then you double 2, you get 4. You double 4, you get 8, and then it keeps going up. You see 16, 32, 64, and 128. So each time it's doubling.
Mhm.
And
So-
go ahead, Diego.
I'm sorry. Up here is the amount of bits. In here is what it does. So if you'll notice, 2 to the 0, for those that love algebra, can somebody tell me what is 2 to the 0?
0.
0.
0.
Ouch. It is 1.
Yeah,
2 to the 0 is actually 1. Believe it or not. Now 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. And 2 to the 7th is 128. That is why it's called binary, because it's either on or off, and it is a base 2 numbering system compared to what we are accustomed, which is a base 10 numbering system. So depending on which bit it turns on, it then calculates 2 to the 0 up to 2 to the 7. So if I just turn on this and I send a byte of information, it'll literally send across the network 1 0 0 0 0 0 0 0. On the other end, it knows that means 128. Does that make sense?
Yes.
All right. So my challenge to you guys is, first, the easiest one. Memorize this little game of 1, 2, 4, 8, 16, 32, 64, 128. After you got that one down packed, what you need to try next is 0, 128, 192, Now I just want to mess myself. 192, 224, 240, 248, 252. Jesus, it's been a while. My brain has to do that. And 254, 255. What did I just say? I actually said this. Watch. 128. Look at the green box up here. See the green box? That's 128. Watch when I turn on the next one. 192. Watch when I turn on the next one. 224. Next one. 240. Next one. 248. Next one. 252, 254, and 255. Those are the most important things you guys got to be able to memorize. It's going to be 1, 2, 4, 8, 16, 32, 64, 128. After you get bored with that, if you really want to make your life easy, you've got to memorize the next set of numbers, which is going to help you when it comes to classes of networks, which we're going to get to tomorrow, and subnetting, which you would get in a great in a different, completely different topic, would be networking, Network Plus, on how to subnet. But understanding how these numbers work are going to help you when it comes to figuring out where you are when we get to the point of what we consider subnetting and the subnet classes, the A's, the B's, the C's, D's. Without those numbers memorized, it is going to be the most tedious and pain in the butt thing you're going to have to do. And it's as simple as just memorizing 1, 2, 4, 8, 16, 32, 64, 128, 128, 192, 224, 240, 248, 252, 254, and 255.
And all
Trust
you're
me.
doing at this point is doubling the numbers, right?
Yeah, all I'm doing is actually, it's memorized at that point in my head. But yes, that is correct. I am doubling the numbers while I'm going up every single time because the value gets doubled. And then, but when I'm coming backwards, the reason why I'm doing that, all I'm doing is just turning on the bits. We're going to give you guys this Excel sheet so you'll be able to practice turning on these bits. Why? Because of the fact that, one, the classes are that way, and eventually when you get to the harder part, if you're going for Network Plus or if you're going for Advanced, you need to understand the other numbers, which is, it starts from left to right. It turns on the bits little by little. It turns on the first the 128 bit, then it turns on the 64 bit. So 128 plus 64 is equal to 192. Then it turns on the next bit. As soon as it turns on that next bit, it becomes 224. Then it goes again. He turns on the next bit for the network. Like that. 240, because 16 plus the 224 is 240. You got 248, 252, 254, and then 255. But the first one you really got to memorize is that one right there. You get this one down packed, the other one is just slowly but surely. And it will help you when it comes to classes and understanding what you're looking at. Because without memorizing that, it's going to be a pain in the butt because now you got to memorize everything else. Because as soon as I give you what I just gave you, if you can memorize that, then you could actually calculate the rest and you don't need to be able to, you don't have to memorize anything else. Everything else is just trying to calculate and it starts becoming part of your memory anyways. Questions or doubts on a whole byte of binary information and how to count? All right. So now that we learned how to count, in here they're only asking us know how to count up to 15. At the same time, hexadecimal, for those that do not know, and I believe I stated a little while ago, it is a 16 base. So we went from 10 base all the way down to base 2, now all the way up to base 16. In the world of hexadecimal, all values are identical to themselves. 0 is 0, 9 is 9. Now, anything above 9 becomes a letter up to F. So 10 is A, B is 11, C is 12, D is 13, E is 14, and F is 15. Questions?
If you see a MAC address with a letter in it over F, it is an invalid address.
That is the most important part, is being able to read and say, hey, that's not right. For the purpose of this test, later on, you've got to be able to actually turn everything back and forth. But we've got to understand where it's coming from. They're not, that I'm aware of, I've yet to run anybody to tell me they went into CompTIA and gave you a hexadecimal address and told you to go change it into binary. That's not happening. But you got to know what it is, and you got to understand what's a legitimate value. That we must know at this point. You could always think about A+ being, I would say, consider being going to ITF is, I said kindergarten. A+ I would say somewhere in your 1st to 9th grade. You got Network Plus, Security Plus, PCNAs. Those get a little harder. That's just me trying to be nice, reference to being a little bit harder. Anybody shocked yet? Ready to kill me?
Mr. Diego,
Yeah.
just to confirm, anything above 9 is a letter, and
Is a
you
letter
said
in hexadecimal. Mhm.
regarding to the example, so it will turn into a letter, so it can't be above E then, right? It has to be A through E. I'm just trying to follow
A
here.
through F.
F.
A through F.
And if you
Any,
see
yeah, if you see G, H, any other letter except for A through F, it's not a hexadecimal value. It's not a
Okay.
legitimate hexadecimal value.
Okay, got it.
And if you look here, this essentially is 1 byte that they have broken down into 2 letters for hexadecimal. So you get the first part of it, which is E, which is the 1, 1, 1, 0. And then you have the 0, which is just 4 zeros.
So that would be the hexadecimal value of E0 into binary. Now, what's amazing is that, I'm not sure if we have it here yet, there is exercise to go from hexadecimal to binary and binary to decimal. And you'll be surprised how easy it is for your brain to actually go from binary to hexadecimal and hexadecimal to binary. And it will find it much harder to go from decimal to binary or to hexadecimal. It's amazing how easy it is.
Yeah, we have a game for you guys for tomorrow to practice.
Now the only thing is that you get $100 if you're able to beat me. That's 51. Good luck on that one.
Challenge accepted.
Challenge accepted. You only got a day, so good luck with that one.
I think Laz was the second highest. He was 30.
Yeah. I still remember I had to do it in front of the class. They couldn't believe it. Like, what the? Yeah. All right. Any other questions here?
Just want to confirm, you said letter over F, it's an invalid address, correct?
Correct. So if you had this address down here and instead of E, it had an H. So if it was H0, CB, 4E, 930278, that would be an invalid MAC address because of the H exceed what we got.
Okay. Got it.
Yeah, and that's where they're gonna try to
Thank
mess
you,
with
sir.
you. They're gonna give you invalid characters to see if you could recognize a legitimate address. That's basically what they're gonna do to you. That's the only thing that's good here is that they're not gonna be going hardcore trying to tell you to change anything. But you must understand it because it's only gonna get harder when you get to the other subjects. But if you don't understand this now and you don't get it nipped in the bud, when you get to the harder ones like Network Plus, Security Plus, CCNA, or any of the other stuff, you're gonna be like, I wish I would have spent a little time understanding what this was. Just the basics. As long as we get the basics, we don't have to be professional. We don't gotta get the 53. Some of us are happy just to get past 5. All kidding aside, seriously, any other questions? All right, next slide. Yeah, of course, why not? Our visual representation of things and how they are. If you'll notice here on starting from left to right, on the left side over here, we have a switch, then we have a bridge, and then we have a router that's going out of the office, and lastly, we have a repeater. You'll notice there that the bridge is in between one to the other, so most likely it's changing from one to the other. You have your switch over here, which has a repeater on the bottom. So that's probably an office that's out way out there. The repeater is repeating the signal from the switch. The bridge is bridging whatever's coming from the router to the switch. Just a visual representation of the information. One repeats and keeps the exact same media, which is the repeater. The bridge does not keep the media. So it's, changing maybe Ethernet to token ring or copper to fiber, something like that. Questions?
Is bridge is it a device? Is that actual?
I'm sorry?
Is bridge is a device?
Yes.
A bridge it is all of these 3 devices can be sometimes the same device can be configured to run as different modes, all right? But they're all, you can consider usually on a LAN, usually. With the exception of the router, which the router is connected to the LAN and the WAN at the same time because it grabs your LAN segment and it forwards it out to the intranet or the internet, depending on what you want. So they're just showing you a visual representation of where you could see these things in the network. The real one that you'll find a lot is a switch. You'll find that like bread and butter on these LANs. They're just showing you here a representation of a bridge in the middle of it, and then a repeater, which is repeating it to God only knows where out there. We just need to be able to decipher. The main thing here is know what a switch is, and then be able to decipher from a bridge and a repeater. The bridge will bridge 2 different physical connections, while the repeater will repeat the exact same signaling, like your Wi-Fi repeater or any other repeater, or fiber repeater or Ethernet repeater.
Oh, okay. So are we still nowadays the network using these bridge devices? Because I haven't seen this one, because nowadays switches have their own, maybe if it is the other network is working with Ethernet, there are some modules or SFPs so that we can just switch to the other medium. So can we see that?
Yeah, you could always think of the module, for instance, like on those smart managed switches that you say, you could always think as the module, that fiber module being its bridge.
Yeah, So can we say that that is a bridge? We can,
The connection is the bridge, the fiber connection from one room to the other. But remember that both of them, though, in that instance, would be fiber to fiber. So in that instance, it's not, because it's just connecting the two. But let's say it would have been fiber to copper, then that's a bridge. Because it's bridging two different medias. And that's what it's doing. It's bridging the two different medias. Something that's not compatible with the other. I can't get a coupler and just connect these two together, right? There's no way I could just get where it's the exact same signal and everything. That device in the middle will change the light signal to electricity and vice versa.
okay, thank you.
That's his job. It's just basically in reference to making sure that on the network, it's able to change the actual physical media and the way it transmits. Any other questions on either a bridge, router, or a switch repeater? One of those. Okay, next slide, please. Hubs, oh my. As we said, hubs are the dumbest things in the world. They are usually in a star topology. The other ones that we have capabilities of doing that in the actual wireless models, which is the actual access points, they can play as dumb as a hub. They're not as smart as a switch. It broadcasts the signal, as we know. Questions or doubts? So this is the guy that screams out to everybody. He lets everybody know what you're doing. He's not smart enough to decipher. And it is a layer 1 device. That is correct. Any questions, doubts? All right. Next slide, please. Switches. These are guys that look almost identical to their cousin, but now they rely on layer 2. They're actually smart enough. The only variance between these guys is that either they're managed or unmanaged. A managed switch lets you create VLANs and lets you manage the switch, put an IP on it so you can remote to it. It doesn't do its work in IP, but you can program it with IP so that you can get it through it, obviously remotely. It is able to obviously replace, and it's much more superior than an actual hub because of the fact that at the moment that it learns where you are on a port, it does not require to figure out again anything. It automatically knows where the MAC address is, and it automatically routes the packet to the correct port without having to scream it to everybody else. Questions? Now, this is the part that I always forget the terminology. The hub, it's its own collision domain, if I remember correct. That means that the whole entire hub is one collision domain, while the switch, each port, it's its own collision domain.
Wait,
Everyone know what a collision is?
so on the hub,
That would be Ethernet too, yeah.
everything that comes off of the hub is a collision domain, which basically means only one can talk at a time. That's it. If two people, like two computers talk at the exact same time, you actually have a collision of data. And that's where this CSMA CD, I know my writing is absolutely awful. So
For Ethernet.
for Ethernet. So you
CSM,
have
yeah.
carrier sense multiple access collision detection. So basically, this is something that's built into the computers. If a collision occurs, so if two computers try to talk at the same time, a collision happens. Then what happens is internally in these computers, they back off and stop transmitting for a random set of
Prime
time.
number.
They have like a dice with like a million different.
Yeah, they have
you
a
know,
prime, yeah, they have the prime number that they multiply by, depending, like you said, depending on the time of day or whatever, they throw that prime number into the equation and they're able to retransmit, and nobody retransmits at the exact same time.
Yeah, because we're talking like milliseconds. So that's what the CSMA CD is, carrier sense multiple access collision detection. So once it detects a collision, everybody backs off, waits for a certain amount of time, and then they try to retransmit again. So on a hub, when you have 4, 5, 6, 7, 8, the more computers you add, the more likelihood you're going to have collisions. So that's that collision domain. When you get to a switch, each port on the switch is its own collision domain. So every single port by itself is its own collision domain. So it's breaking all that stuff up. It really minimizes this from happening. The only way it could really happen is to say if you attached a hub to this switch and had 5 or 6 computers on that hub, then you would have 5 or 6 computers in its own collision domain, and then it could possibly happen again more.
Yeah, and that's where when you're troubleshooting and you run into these things, you're gonna see it a lot. Well, at least back in the days, we used to see it a lot. As soon as a network engineer saw a hub on a network, they were just having a whole fit about the whole situation because of the fact that those things were removed from the network and we're not expecting them to be on the network. Even though obviously some people try to circumvent it, we just need to be fully aware of the effects, what a hub does and what a switch does. This is its main difference. On top of it, there's managed switch, which is a much more smarter switch, but just the dumbed down versions of it, the ones that there's nothing to configure. A switch is much smarter because of the fact that each port is its own collision domain and it has a reference table that it checks. Questions?
Yes, Will.
What's the name of that device again that has many ports? Rookie question.
Switch?
They call it switch?
The
Okay.
switch?
Yeah, thank you.
Yeah.
Well, wait, I mean, they both have a lot of ports. I mean, which one are you speaking
There's a
of?
hub and there's a switch.
Okay, I know the hub is only works with one collision domain.
Yeah, and that's the one that screams out to everybody. Everything that comes in one is screamed out on every port that's on that hub.
On that hub, okay. So
And they look identical. If you put two of these one next to each other, and I didn't tell you which one was a switch or you didn't read the label, they'll look identical.
Yeah.
Yeah, that's
Equipment wise, physical wise, they look identical.
they look identical. Yeah, so what would be the switch here?
The bottom one here would be the switch.
Got it. Okay.
I mean, technically, you know,
Either
they both are
or.
switches. This would be an unmanaged switch, and typically this would be a managed switch.
Yeah, I would have to agree with that.
So
The bottom one looks like you can program it.
yeah. So the upper one is like what you would see in your house or something like that. If you're going to set it up, you basically it's plug and play. You plug everything in. It starts feeling around who everybody is. Says, okay, I know all these MAC addresses. I know who everybody is. We're good to go. And then it's able to do its job just fine.
A switch. Okay.
Yeah, that's an unmanaged switch. It means there's no programming involved. You literally plug it in and it works.
Okay. I follow. Okay. And
Now a managed switch, you can program like if it was a router and you could tell it what each port is doing. You could actually control, turn off the ports, turn them on. You could change the speed. You could do anything you want to every single port. You could even tell it that its its domain or virtual LAN is really the key thing. You could separate it virtually so that each port is completely like if it was 24 different switches.
Yeah.
Where none of them could see each other. And that would be a managed switch where you're able to program and tell every single port what it can do.
So like in the groupings that we're showing in this lower switch down here, if we had accounting, HR, and operations operating on the same office, but we don't want them on the same networks, like basically communicating with each other. We can make it so they can't see each other by creating a virtual LAN. So we could say this group here that's boxed in yellow, say that's accounting. This group that's boxed in green, that's HR. So HR can only see HR, accounting can only see accounting, and then the
Okay.
group in the middle would be operations, and they can only see operations. So it's operating like 3 separate LANs, but we're doing this virtually. So that's why we call it a virtual LAN.
Okay, so at the bottom, it's a managed switch. Then
Yes.
managed switch handles every different departments. I think I remember you mentioned it a while back.
Yeah, and a managed one, we would program it and tell it how we wanted it to operate.
And usually unmanaged will be in a home, just like
Yeah, unmanaged, this top one, you plug and play. You plug it in and it does exactly what it needs to do. It separates everything by MAC address, prevents any collisions, and allows people to communicate more efficiently.
Capiche?
Yeah, but it can't do quality of service. It won't be able to turn off on and ports, and you can't remotely administer it. That's what the unmanaged one does. Says it just does its job and that's it.
It does.
There's no way you can program it. Yeah.
One follow-up question, and before I'm done, the star topology, is it used? Just to follow, it's a hub, right? It's being managed by all the computers, or is it?
You could use a hub or a switch at the center of the topology.
Okay, capiche. Okay, thank you.
Okay. Next slide. No questions. Right, devices on the network, we have our bridge and our gateway. As I said before, our bridges are basically connecting two physical dissimilar networks. Your wired Ethernet to wireless Ethernet, your fiber optics to your Ethernet copper. That basically is doing exactly those physical mediums that are completely different and allowing them to obviously bridge that connection. Now your gateway, those hopefully a lot of us are very familiar with that, is usually the router. This guy is the one that connects two logically dissimilar networks. Logically now means digitally, means in the logical or virtual world. Token ring to Ethernet, LAN to WAN, LAN to MAN. That is logically completely dissimilar. Both of them could have copper, but the logical portion is where the gateway comes into play. Not to be confused with a repeater. The repeater repeats the existing signal and network. A gateway does not. Will, I think you have a question.
You still have your hand up, Will.
Oh no, I didn't raise my hand. No, sir.
Okay. No problem. Any questions, doubts on a bridge or a gateway? Okay, next slide, please.
Oh, sorry.
Go ahead, Scott. You had a question?
Just one question. Could bridge ever be?
Yes, Scott. Got a question?
Yeah, sorry. I was having trouble with my button for some reason. My question is, could bridge ever connect to LAN or WAN, or no? It's just more just like a connector between the Ethernet and the wireless Ethernet. If my question makes sense.
A bridge is made to help with the physical connection, to be able to change from a physical connection to another, be fiber optics to copper, wireless to copper. It's changing the media.
But you could use as an example of connecting a bridge from, you know, a LAN to a WAN. You can actually go into your wireless, your router that you got from Comcast and set it to bridge mode. So you can have it come in and it changes from the WAN, from the wide area network of the internet into the LAN, which is your home network, and you're bridging it over to, say, a wireless router that you have, and then converting it to a wireless signal. So you can technically do it, but that is not its primary function. Usually it's connecting intra networks together.
Yeah.
Oh,
I understand what you're saying. Yeah, you're right. You could put technically your ISP's modem into bridge mode. And in doing that, now it will then bridge its connection to your wireless router, whatever it is that you have inside your house.
okay. All right, sounds good. Thank you, sir.
Now, your routers themselves are these doohickeys. You have your small little one in the bottom, cute guy. Usually you know him. He's a Soho ones, a small office, home office. And then you got the guy in the middle and the top, which are your managed full-blown routers. Both of them do the exact same job, vice versa, that some of them have much more robust security purposes compared to the other ones may have some more features. What do I mean by that? The top one will probably be the most robust one, where you can go fully hard coding every single little thing that you can think of. The bottom one is an all-in-one. If you'll notice, he's got a switch, which a lot of us hopefully recognize now. He's got also access point because he's got those antennas on it. And he's also a router because he actually takes the actual ISP connection and he routes it into your internal and vice versa. So depending obviously where you are, if you are in a small office, home office, you will be using the bottom one. And inside your corporate or mid to big offices, usually they're using the managed routers on the top. Now notice there in the ports, even they put little colors again in the back here, just to let you know in the WIC card, there is that blue one with the actual port that's next to the power to the right. Then you actually have your LAN segment cables that you can actually connect on the left. Questions or doubts? Slide, please. All right, next one is our firewall. This puppy here is made to protect us. Just like in regular life, firewalls are there to protect from fire. In this case, this guy here, it should be either software or hardware, depending if it's software on a given unit or computer or servers may have a software firewall, or like Windows likes to call it Windows Defender. God only knows why they call that a firewall, but we could just play with them and agree with them. Either which way, these appliances are made to keep you safe. They have a set of rules or access control list to be able to facilitate the packet filtering within it. It inspects the actual packet based on a set of rules, and then depending on the rules, it will let the actual traffic come through. There is the ones that are stateful firewalls, and that one allows traffic originating from inside the network, but it blocks all originating from the internet. Stateless firewalls is the ones that are based on packet filtering itself, and then it itself, based on those set of rules, then it could allow you. Very dangerous thing about stateful is that it requires a lot of time for it to state exactly what it is. So therefore, the stateful ones are much more a pain in the butt to get up and running than the stateless or the packet filtering firewalls. Questions, doubts?
So Diego, can you
We're
repeat
getting
again?
firewalls a little bit more later, so it might make a little more sense. What were your, what was your
We'll go
question?
into detail on each one. I'm sorry, that what?
I was just gonna ask, can you just repeat one more time what you just stated? The reason why the stateful firewall is more of a pain in the butt. Why is it?
You have to state exactly the traffic that's being allowed. So if I'm saying A can talk to B, but I also want it to be able to talk to C, and I don't put that, it's not gonna happen. Now, I want to allow A to talk to B, but I didn't put B can talk to A, I'm not gonna allow it. Because it has to state it. And that's why it says stateful. It must state, is it allowed or not? Just because A is able to talk to B, it doesn't mean that B is allowed to talk to A. Now, in the packet filtering or in the stateless one, it has a set of rules. Based on those rules, then it determines if it allows that type of traffic, and it doesn't need it on both ways. It doesn't have to state exactly what it is.
Got it. Thank you.
A lot of these routers use, a lot of these firewalls usually use either a whitelist or a blacklist. The whitelist is usually the easiest one to deal with because of the fact that all firewalls, the last rule, although it's never written, it is called the implicit deny. Anything that has an ACL automatically has an implicit deny at the end. Now I have the whitelist that says, hey, A can talk to B, B can talk to C, yada, yada. When it gets to the end, if the rule is not there, you must acquit. You drop the packet and you let it go. Why? Because it wasn't here. That means the implicit deny has just came in. And since the rule is not here, the last rule means nothing can go through, then therefore, that is a reason the person can't get through.
ACL stands for Access Control List.
Now, that is the whitelist, which is usually easy because now I'm going and saying, go ahead, let them do that, let them do that, let them do that, let them do that. And eventually it's going to say, okay, it's not on this list, you can't do it. The worst one and the most dangerous one, in my eyes, unfortunately, would have to be the blacklist. Because of the fact that now I'm going to tell you exactly what you cannot do. And that's the thing I hated from English class. Everybody and their mom was telling me what to do in English, but nobody told me exactly how to spell in English, but they surely gave me every rule of what I wasn't supposed to do. So if you could just imagine, if I'm telling you 5 million things of what you cannot do, that's the blacklist. What's the last rule after I just told you 500 times you can't do something? And now I don't put anything. What's the last rule that I just said? Anybody? Remember what's the last? What's the normal rule right now that I said? If I write everything and then the last one, even though it's not written, it's called the implicit what? Deny. It's always going to deny at the end. If it's not written, it is denied. So what happens in the blacklist, and a lot of people don't notice or they forget when they're troubleshooting, is they went through a whole list of a whole bunch of stuff saying, no, you can't do this. And they forget to put the most important line at the end, which is fully allow everything. You could just imagine how dangerous that is on that blacklist. Because yes, I gave you a 500-line essay of what not to do, but I just circumvented everything that if it's not on this list, if it's not on the 500 things I told you not to do, that 501 just said that you could do anything you want. Because I have to put it in there, because if not, I just wrote 500 lines of what you can't do, and then 501 is going to say implicit deny all. So yeah, you just spend 5 hours writing code where everything's being blocked. So the last line will have to be to allow everything. And it gets very dangerous if you're not very, very picky about the blacklist. Questions, concerns? Next slide, please. Right. We have our coaxial cable itself. There is different flavors of this guy. Overall, the RJ59 and RJ58 were the ones that are being used a lot. And the ones that we might recognize a lot is the RJ6. The one that replaced 58 was 59, therefore you won't see 58 that much. RJ6 is still being used within the actual cable companies for long distances to be able to have, obviously provide the service. Inside your house though, inside there, if you'll notice, there goes the 50 ohm on the bottom that I was talking about. And in these cases, in this one here, it's 75 ohms. So you'll notice there that old legacy 50 ohm that I was mentioning earlier in the old ring topology. And that would be with a multimeter, you can actually read the ohms on the wire. Questions, doubts? It is resistant, keyword. So is those cheap watches, right? They're water resistant. That doesn't mean that it is completely impervious to electromagnetic interference, but it is, out of all the copper, the one that is resistant without going into any other details. Obviously, you'll see there the braided shield, you have the jacket, you have a I can never pronounce that one, dielectric core, which is that white guy, and then the center conductor, which is the copper itself. Next slide, please. On these specific cables, your 10-base-2 Ethernet cables, networks, even tokering used a lot these big connectors or BNC, whichever way you want to call it. Ones that you're probably very familiar are your F connectors. That's the ones that are usually on the back of your cable boxes. With a screw is your F, twist and lock is the BNC. The BNC connectors are one of the preferred ones out of them when it comes to networking because of the fact that it locks into place and there is no threading, so there's no dangerous things of you messing it up with the threading.
Allows for easy removal and reconnect.
Questions, doubts? Next slide, please. All right, STP or shielded twisted pair. This puppy right here is made to be able to avoid EMI interference. It doesn't completely block it, it just helps. In here, you'll notice that this puppy has a nice, beautiful metallic shielding around the actual copper plastic shielding that it has to be able to help with the EMI interference. No guarantees, but it does help when it comes to EMI interference. Questions? Everyone know what EMI interference is?
Electromagnetic interference.
There we go. Any other questions here? Do we understand why these things are being twisted?
To prevent
Anyone want to
crosstalk.
tell me? Thank you. Yes, somebody's ready. To prevent crosstalk, because of the fact that this is electrical currency, therefore they actually twist each and every color a different amount of twist. You could even see it there, that green and the difference between green and brown is pretty obvious, the amount of times that it is twisted. That is to basically avoid from it jumping from one wire to another. Since it is electricity, they want to avoid that crosstalk.
And by twisting it, they actually, it sets it up so that the cables cross each other at a 90-degree angle whenever they cross, so the signals aren't traveling in the same direction. And that's part of what
Mhm.
negates that crosstalk.
Questions, doubts? If not, next slide. That horrible little tail feather there.
Do what?
You ever make one of these cables?
Yeah.
The
Oh,
little
yeah.
tail feather, that little string there. Oh my
Yeah, it's
God, that's like
Kevlar.
a torture device. Yeah. That's
Yeah, it is a piece of Kevlar to add strength to the cables.
yeah. Want to kill somebody when you're making those cables. All right, my favorite though, unshielded twisting pair. This one's easier to make when you're creating the actual cable. You notice here, although they're all twisted again and in their own way, and they're not all twisted the same, there's not any of that mumbo jumbo in the middle. There is a difference between the one I'm about to show you and the first one that I showed you. And you're going to notice there is a major difference. But one of them is for fire while the other one's for EMI. And this one, this got nothing. This is the cheapest version you have, which is called the UTP, the unshielded twisted pair. They all come in different categories. Just got to be able to recognize the actual media itself. All right. Questions? Next one. So you have your Cat 3s up to your Cat 7s. Cat 3 is the old version, and you most likely see it a lot still going on when it comes to regular analog phone lines. They're still using Cat 3. Our easiest thing in here is 100 meters, 325 feet. If you can't remember that one, just smack yourself for not remembering the number 100, and hopefully by the 100th time you might remember that is 100. There is none of them that can go beyond the 100 meter. There is, though, the factor that the 55 meters when it comes to Cat 6 and the Cat 6A, where if you want the speed, the Cat 6 is up to 55 meters, and then I think Cat 6A does not have that limitation. I don't know why the chart says that. If you want the speed at 10G in Cat 6, it is 55 meters. It can still do 10 gigabyte. I'm sorry, it can still do gigabyte at 100. But if you want the 10G, it is at up to 55 meters on a Cat 6 cable. Questions or doubts? We should hopefully memorize these names too. They may throw these names out there to you. Ethernet, fast Ethernet, gigabit Ethernet.
Kind of like with the
Question.
USBs, when they changed the names of the USBs, they had like super speed, fast USB, all that.
Mm-hmm.
So what's the big difference between Cat 6A and Cat 7?
Shielding. I believe that is correct. Diego, correct me if I'm wrong, please. But I believe Cat 7 is a shielded medium. Not extremely common yet, because it is rather expensive.
It is the latest and greatest, but I don't think it's a standard. What I mean by standard is it's not a mandate. There's not too many people with 10G inside their network. There's not too many LANs at 10G. You just got to be able to decipher in itself on the speed. And Because I don't think Cat 6 really, because there's even Cat 8 now. So let's not even get into that discussions. Maybe. Is it 6A and 7? Is that the power over Ethernet thing? No, that would be 6, right?
I
6
think
is the
6
power
is
over
PoE.
Ethernet?
Yeah, I think 6 is PoE.
Okay. But that would be the other thing that you need to know. Power over Ethernet is a 6 and above. And then I think Cat 5 and 5E, those are the ones that they might mess with you in. So knowing Cat 3, Cat 5, Cat 5E, I would say those are the ones that they're really going to be testing you with. And then maybe 6 and 6A, the only other things I can think of. I don't think I've seen anything really.
Well,
A lot of people
going
saying
from
anything about
was
7.
it Cat 5 to Cat 5E, they went from using 4 of the wires to using all 8.
Correct, because of the gigabit Ethernet. Good call. Any of the cats before Cat 5E only use 4 wires. That would be your orange, white, your orange, your white, green, and your green. But on 5E and above, if you want gigabit, you need to use all wires. Good catch there. I almost forgot about that part. I can't believe I forgot that part. I still remember the crossover cable when it didn't work. Should have seen my face. Like, damn, I know how to make a crossover cable. There it is. Questions, doubts on the categories. These are the categories, the types. They're all going to look the same. So the cable is still going to be either unshielded or a shielded twisted pair, right? It's still going to look the same. It's the category of cable so that you know what is its maximum length and what is his maximum data rate that it will transmit in. All right, next one. All right, your twisted pairs come in 2 flavors and connecting. Like I said, your Cat 3 is still being used for your phone lines. So you have your RJ45 or your RJ11. Your RJ45 is your typical 8-pin connectors used nowadays in Ethernet and was used also in Token Ring. You have your RJ11, which is a 2 to 4-pin connector used primarily for your phone lines. Phone analog lines. Phone analog lines. Can I say that one more time? Yeah, I could. Phone analog lines. Why? Because I could just see the question coming. You're going to say, well, Diego, how did this Cisco phone get an Ethernet cable? That, my friend, is a digital phone line. And it may even be a voice over IP phone that you're looking at. Not to be confused with an analog phone line. 2 different types of phone lines. Questions or doubts?
Emmanuel looked it up for us. Cat 8 is a 40 gigabit line.
Woohoo!
I imagine it is very rarely used at this point. A gold-plated cable.
Yeah. Hey, there's nobody, just think about it. You know, this is what frustrates me about these things. In computer, you're always as slow as your slow. You're as fast as your slowest link. Let me rephrase that. You're as fast as your slowest link. So if you got a 256K or 256, no, that doesn't exist anymore, 256K modem. You only have like 100 megabytes or maybe 10 megabytes for download. What are you doing with this 80 gigs? Does it make sense? Do you have a humongous server at home that's going to require this bandwidth for you to be downloading and streaming back and forth?
Yeah.
So you just got to be careful what you buy, because sometimes they just sell you these things that you're never going to use.
Also, I mean, be aware of the medium you're using with your devices, because you want to bring a network down real quick, plug in a Cat 5 cable into a Cat 6 switch network.
Oh yeah, that'll take it down.
It will bring down that network quick. And good luck trying to figure it out if all you have is just blue cables coming out. And you've got to narrow down which one of those is that Cat 5. I mean, they have things that will help you narrow it down and figure it out, but you have to pay attention to your medium. We had a young lady in the first cohort I did with Diego, where, you know, her husband was constantly buying just the cheapest HDMI cables he could find. And she finds out halfway through the class that there really is a difference.
Yeah.
And she's like, oh, this time I thought it was, you know, the cable box or the cable company wasn't giving us the right, you know, what we were paying for, but it was the cable we were using in between the cable box and the TV.
Yeah. You'll be surprised, yeah, man. Especially that for people that love gaming, man, they'll know real quick what's a good HDMI cable versus the cheap ones. Those real high quality ones, man, it's just amazing how smooth and how crisp it is compared to the cheap cables. Any questions on this? All right, next slide. We're all professionals, man. You had me all worried here. Ooh, here we go. Humpty Dumpty fell off the wall. Now, my friends, you could play the game all you want and you can learn these songs, but my friends, I unfortunately had to learn this the hard way. A and B. Your top one is B and the bottom one is A, right? Yeah, orange.
Yeah, that is correct.
Hey, look, it has a label. Okay, it has a label. Oh, so I'm right. Orange is B, and the only reason I know that is because UPS used B for almost all their life. And orange, you glad that I had them first. Ooh, just how fun. Either which way, I'm not trying to make a joke, but just remember this only fact when you're doing wiring. The white one is always first. I'm not trying to make a joke, seriously. The white one is always first. Now watch what happens. White, orange, orange, white, green, blue, green, white, brown, brown. And I did that with my eyes closed. I don't know if you noticed. Now, there's always a white proceeding with a color. There's always a white proceeding with a color. It's always a white and then a color. Unfortunately, there is some weird songs. I think there's Humpty Dumpty fell off the walls on the next slide to be able to help us this. Either which way, we need to realize what flip-flops here is the oranges and the green. If we could just memorize only one of them, it at least we'll be able to figure out what the other one is. So B starts with orange. If I flip-flop the colors of wherever orange is and wherever green is, I'm gonna have A. So now I'm gonna go white, green, green, white, orange, blue, white, blue. Anybody? Come on, orange, orange, white, brown, brown. So the only two that flip-flop. Now, dangerous. We'll notice here that 4 and 5 and 7 and 8 do not move. Blue and brown do not move. They always stay where they are. So what I always remembered is all the B's are staying where they are. Blue, brown, they're there. That's the way I remember. Blue and brown stay where they are. Orange and green, they can go anywhere in between. Either which way, you have this beautiful, nice song coming up. Next slide, please. For those that love mnemonics, not sure who came up with this. This is the first time when I first started teaching this class that I heard of this. And there's trees to the sky because there's green, obviously. Brown to the ground because that's the brown one on the bottom. And a river runs in through the actual sunny day. You see the blue in the middle, and then you can pretend that there's a ray of sunshine on both sides of that river. Again, now they go and play more or less the same thing with B, where they're saying the sun's to the sky, and you have the brown to the ground still, but now this time the river runs in between a valley, which you'll see the green is surrounding the blue river. My friends, I can't memorize half of the sentence I just said. I actually went to the trouble of memorizing the colors. I guess I'm just so old, I can't remember nursery rhymes. Now, another thing that we need to notice is in this beautiful picture, which they didn't include, is that the teeth must be pointing to you. So if we can bring in a picture of a connector, please, and the bottom of it from the internet, they can see the gold teeth, please.
All right, 1 second.
And because of the fact that if you do it the other way around, then it's not pin 1 through 8. You're going to be doing pins 8 through 1, and it will not work. So therefore, when you're actually creating the cable, you need to face the gold pins to you and then stick in the wires from the back into there. Here he is. I got one.
Got it right here.
Oh, you got it? Hey, all right. There he is. Oh my God, those are the real hectic ones. All right, that one goes all the way through. But you see, there goes the teeth. And now, can somebody tell me what is that color code that they're using? Is it A or B? Is it A or B?
That's a B, right?
That is correct. It starts with orange, so it should be a B. Because we go from left to right, looking from the blue side of the cable towards the gold teeth to be able to decipher where we're starting from. Questions or doubts on deciphering what's A and what's B? That's all about memorizing things. And that's the only thing that will help you when it comes to questions, doubts. All right, so that's A and B. Next slide, please. Jeez, already up to 50 emails. Can anybody go home? Oh, back to our previous program. Here we are, plenum, plenum, and plenum. This guy here is usually here for fire. He is the one that is rated, and he is even worse than that other guy. You thought the first guy I showed you was hard to make? This guy, you feel like for really going, grabbing the cable and just bullwhipping somebody with this cable because it destroys your hand. You'll see that it has a middle insulation, which is that little white thing there. There's actually a white thing that surrounds, or the metal that surrounds the actual each wire, and in between each wire there is a big little thing in there in the middle. You see that white gap in the middle? That usually is a big plastic thing that's separating every single set of wire. It has got to be the most annoying cable you could ever work with when if you're doing a tip on. Obviously, it's a great thing because it's a fire. I'm sorry?
But occasionally you'll come across that plastic separator in UTP, just regular UTP as well.
That is true. Depending on how much it costs, some of them do have that plastic separator too. But this one is like you got a very high chance it's in there.
Yeah.
Alrighty then. So questions on the plenum. Its main purpose is for that. It's a fire retardant, and it's made to obviously avoid any type of poisonous gases coming in through the actual ventilation systems inside the building.
Big question alert on that one. If you ever hear it's going to go into a drop ceiling, HVA system, or something along that lines, they're going to ask you, what type of cable do you need to use? And it's going to be plenum. Anything where you might experience a fire and people might come in contact with that smoke, that is going to be the grade of cable that they want.
Next slide, if there's no questions on this one. Fiber optics. All right, guys. The first thing I say is keep this out of your mouth. That's all I gotta say. Next slide. I'm just kidding. Nah, I'm not kidding, man. Seriously, man, you'd be surprised how many people try to peel this thing with their mouth. Don't do that. That's fiberglass. If anybody knows what fiberglass is, it's got to be the most dangerous thing you could put in your mouth. If that fiberglass, that little hair just happens to go right into your tongue, goodbye to you and your veins. God only knows when it's going to hit the heart. Either which way, this is what it looks like. It has an outer jacket for protecting. It has then a strength member to make sure that you don't break the glass on the inside. Then you have a little coating and the actual cladding, which is a little thing that a lot of people love to peel with their teeth. Don't ask me why they love peeling that little blue cladding off with their teeth. I got no clue. There's special tools that allow you to be able to peel these things and to terminate these cables correctly. You have a 99% chance that you will never be asked, like I did, to terminate a cable, unless if you become a fiber optic terminator person that, like me, that went in and specialized on that. This is not a common thing of terminating. Usually they come with their tips already on. What we do need to understand is that it is a laser or an LED, depending on the actual type. It can be multi-mode fiber, or it could be single mode fiber. So you have your long hauls, which are your single mode fibers, and you have your short hauls, which are your multi-mode fibers. So you'll either see SH with MMF, multi-mode fiber, or LH, long haul, with SMF. They'll intertwine or interchange, these two words with each other, just to tick you off and confuse the living thing outside of you. They'll just all of a sudden say short haul, just to see if you think it's single mode. When short haul is the multi-mode fiber. That's the one that goes short distances. Questions or doubts? Now, this is completely no chance at all of EMI interference, completely immune compared to the other ones I told you that they're resistant and or may not interfere. No, this guy, if there's some type of interference, then I'm not sure what you're doing, because light and electricity.
Probably have a crack in the cable somewhere.
Yeah, maybe, I'm not sure. Gotta be something else. It makes sense. No electricity. One's light, one's electrical. Therefore, there can't be electrical magnetic interference in light.
And as the name suggests, single mode is it is a single laser pointing down the line, and you can get long distances out of it. Multi-mode, they're using up to three different types of lasers shooting into it at the same time. And it's bouncing around in there, and the reflection is what decreases the amount of distance you could actually have.
And single mode is much more expensive than multi-mode.
So that means, do we have to use another device so that we can receive these three signals receiver?
No, it does it inside the cable. If we go to the next slide, I think, right, show us.
Yeah, there we go.
Yeah, here we go.
Sorry.
So the module itself, with the connector that you go and you connect it to the actual device, the module itself will have three lasers that is using when it comes to multi-mode. And inside that glass, it'll bounce, as you can see, up and down when it comes to the ones that are on the outer. And then you got a one that's going straight down the middle for its signaling. This laser is visible. The most dangerous laser, and this one a lot of times is an LED instead of a laser, the multi-mode. The one that's really dangerous is your single mode. It is an invisible laser, which everyone loves. Just like I said earlier, everybody loves to go and try to peel it with their teeth. Everybody somehow loves looking at a single mode fiber because they can't see the light. You will never see an invisible laser. Therefore, there's no reason for you to look at a single mode or at a multi-mode. On a multi-mode is as simple as turning off the light, putting a piece of paper, putting the module to see if the one that is transmit, because obviously one's dark and one has light. The one that has transmit, which is on my side, the receive side, it'll be lit up. But the one that is transmit from my side is going to be dark because of the fact that since I didn't connect it to the actual module, it doesn't have anything sending anything through it. So you could only check one at a time. Does it make sense? And with a paper. I wouldn't, or maybe if you can see it on your hand, do not look at it directly. That would be for multi-mode. Single mode, there's nothing else you can do except for have proper equipment to test it and or make sure you're connecting it correctly, which one is transmit and which one's receive. Questions, doubts? All right, next. So you have your fiber types. Where, like on the left, we have our actual multi-mode, single modes. Now, what's kind of easy about this, and the way that I always remember it, and when it comes to speed, the letters are in alphabetical order. Play around with me when it comes to this thing. It even says it in its name. So you have 100 base FX, 1000 base SX, and then 10G SR. If you notice, all of them sound like if I'm saying either S or F at the end. Even when you're talking to people and you're spelling names, a lot of people get confused when you tell them the letter S or if you're saying the letter F. If you can remember that senile way of mind, then you will remember that anything that is either FX or SX or SR is the multi-mode short haul modules. The numbers in the front will tell you the speed. 100 base, 100. 1000 base, 1000. 10G, 10 grand. Pretty simple. Then the other two are very easy. You have 1000 base LX for long haul, or 10G base LR. Again, long haul. Questions, doubts? As for the distance, good luck. I got nothing on that.
I think the 1000 base, I think one of them gets up to almost 40 kilometers.
There is some of them that can go up to, yes, much longer. For the purposes of this course and this test, I don't think they cover those here.
Well, they would ask what like the maximum distance you could do with fiber. And I think that's 40 kilometers. I'll need to confirm that, but I think that's one thing they would ask about. So. Questions? Yes, Will.
If Mr. Dale can repeat what's LR again? What is that? What is the abbreviations of LR again?
Long haul. The L's are for the long haul or single mode modules.
Okay, so
The L stands
LX
for
or
long haul.
LR is long haul for both. LX
Yeah,
and
that's
LR.
right.
Got it.
That is correct. And then FX, SX, SR are the short haul,
Short haul.
which will be multi-mode fiber. We have to be able to use short haul and MMF. We need to be able to recognize those because they're going to mess with us. They're going to interchange those two names like if it was water. You have to know that short haul means multi-mode fiber and long haul means single mode fiber, because they'll do that to you because they got nothing better.
Good to know. Thank you.
And once you exceed these lengths, you need a repeater to read up that signal if you're going to exceed these lengths. So think about it. We have fiber optic connections with Europe. So every 10, 100 kilometers, as they were laying this cable down in the ocean, they would have to plunk a repeater on it and then drop it, and they could hook up the next line. Run another 100 kilometers or whatever the distance was, plunk another repeater on it, keep going. And they did this all the way across the ocean.
Wait, hold on.
Next slide.
This is a rookie question. I'm kind of interested. So it's not from across other continents. It's not the network. It's not internet. It's
Well, how do you think the internet got there?
originally it got there through a fiber optic.
Well, no,
It
originally
is, it's all fiber
ran, like,
optic, yeah.
they ran a copper cable across originally.
Transcontinental used to be called, that is correct. The transcontinental, I don't know if anybody ever heard of that word. Cross-continental cable. It was a massive copper cable that would go from here to the islands, for instance. There's another one that went through Mexico, the one that went to Europe, and the one that went to Asia.
Yep.
A humongous copper cable that went across. That's why if you ever remember, maybe in the movies, or your parents complaining that when they made long distance calls back in the day, they would complain that there was not enough, that their family member in Dominican Republic or in Cuba, that they can't get to it because it's busy. But then they talk to them and they're like, oh no, I haven't been talking to nobody all day, because the transcontinental lines were saturated. There was not enough phone lines, so everybody that picked up, the amount of lines that got to the country was full.
Oh my God.
So the circuit was full, but the person's phone line wasn't busy, but that circuit was full, and you couldn't get across.
And then when
But it's
fiber
all
optic became
some
a deal,
type of medium.
when fiber optic became a thing, they ran fiber optics across to Asia and Europe.
And we also have the internet running off the satellite. So right now, there's internet off of the satellite as a medium. There's internet off of the actual cellular towers, right? And which all, no matter which way you look at it, it's all wireless, right? They've got to hit a landline backbone, be some type of fiber optic connection that takes them into the real internet.
I just like to, because I was checking the max length fiber optic, it's 100 kilometers.
Thank you.
It's the max
Yes,
effective
60
length,
miles.
40 to 60
Yeah, but
miles.
that is
Yeah.
all the, yeah, but that's all depending on the type of connectors. These here that they're talking about are mostly for LAN segments and or something that interconnect. They're not getting into those other ones, which is, I don't remember what type of cable, fiber.
It would still be a single mode. And
Yes, it is single mode, yeah.
yeah, it was,
I do-
but I think that they may ask what is the maximum length for single mode fiber, and that would be the 40 to 60 kilometers.
Also like the power of the laser would also affect the distance as well.
Absolutely.
Agreed.
It's like using a 1 watt laser versus a 5 watt laser.
Yep.
And that's a really big difference for lasers.
Yes,
Mhm.
absolutely.
Any other questions, doubts on this slide? Next one, please. So here is our connectors, and the reason why we shouldn't be putting our mouths on these things, because the majority of them already come with the connector. Now, the way I'm able to remember this is only because I'm that old and senile. When I mentioned earlier our BNC connector, and that was the one that was round with the lock and twist and lock. You guys remember that guy? Everybody remember from the coaxial cable, a BNC connector? Anyone? F connector? Oh man, I'm about to die. Okay. So now if we can remember the BNC connector, and remember that I said that usually that was in a token ring. We'll look at this first one. It is a small version of the BNC. It locks and twists and locks just like the other bayonet connector. This is exactly the same type, but it's obviously different. They look identical, but one's for fiber tips and much smaller. The other one's completely metal. This is plastic. So if we can remember that, then hopefully we can remember the letters ST for token ring. ST, or like they like to call it, straight tip, because it's got that tip sticking out. I just remember it because of the letter T for token ring. Feel me out here. The next one, with my eyes closed, I still play this game, is SC, hopefully, which means C for circle or square. You can pronounce the word square from there. You could hopefully get SC for square if you mispronounce the word and or misspell the word. Gets worse. LC. If you look at LC connectors, it looks like if it has an L. You look at the tip on the top, and then you look at the actual base of the actual unit, it creates the letter L. You see that L using its tip on the top, the little locking mechanism on the top, the little teeth, and you create like the letter L. Do you see it? No?
No,
Yes.
not really. LC, I don't see the.
Can you
L.
change the color to a yellow
Yeah.
on your marker? And there goes the letter L.
Okay.
So this is the only one that has a letter L. This is the only one that looks like an old token ring connector, the first one. The middle one there, I said square, so hopefully we can remember SC for square. And the last one, which is the easy one, is the Michael Jordan guy, the MTRJ. MTRJ is basically has both together. You look at the other ones, those are single connectors. I need to have two connectors to make it. This guy is all encompassed. The wire comes with both fibers intertwined into the connector.
It's also considered a small form factor.
Ooh, interesting to know. But he's the only one that's going to have that Michael Jordan name on. MJ, Mr. MJ. Questions? Doubts? Next slide, please. Okay, hopefully everybody remember my little naming game. Number one. Can somebody tell me what is that type of connector?
SC.
Square.
SC, yeah, my square guy. Bonus points. Anybody know what that color means? That yellow? We didn't say it, but just in case if you happen to notice a pattern.
The speed,
I'm sorry?
the speed of the cable.
That will tell you exactly this. Yeah, it is correct. So the yellow ones is the long haul or single mode cables. And the orange ones are the multi-mode or short haul cables.
Yes.
Okay, just something to know in case if you happen to grab the cable and you're trying to figure out, hopefully you don't have to want to kill somebody because of the fact all you're seeing is the size of the Omicron, and or I don't know what it is. It says how many millimeters, and that's because of the fact if it's a yellow one, you should know exactly what a yellow one is and an orange. It's never going to say the category like in your twisted pair. Your twisted pair, they're very well known of saying Cat 6, Cat 5, Cat 3 on them, but the fiber won't tell you. Usually you won't find that type of numbering stuff on it. Number two, can somebody tell me what type of connector that is? I only said it like 50 million times.
FC.
RJ11, a phone card.
No, two's in the
No,
bottom.
sorry. The
Oh,
one
I'm
to the
sorry.
bottom, not to the right, not to the right.
Now number
I'm
two.
used to it already. Don't worry about it. I always go to the right two until I notice that happens to be three. God only knows. I guess I'm not sure what country we're from here. Number two is the one right under it. Sorry.
That's-
That is big.
Emmanuel said it.
Yeah.
DNC coaxial.
Yes, BNC, bayonet.
Neil Councilman.
Yeah, that guy. You only need to know BNC, so don't worry about it. His full name. I don't think they're ever going to test you on that one. God knows if they do. Number 3. The connector itself, please. What's the name of it?
RJ11.
That is correct. Number 4.
SC.
ST.
We had one of each, so which is it?
ST.
ST?
Straights.
All right.
Creative.
ST for that old token ring looking guy. You see how it's much smaller than the BNC and it has the tip that sticks out, but they both lock it. Number 5.
Number 5 is LC.
LC.
Here we go. Everybody remember number 5 easy, huh?
Has the L shape, yes.
Yeah, there you go. And number 6.
RJ45.
That's his guy. Most famous one you'll probably be touching almost day to day. RJ45.
Oh,
I think that's it. Any questions, concerns? Next slide, please. Woohoo! Tools, and more tools. Your left and rights. Your left is when you're making a male, and or your right guy is when you're making a female. Once again, I'm not trying to be funny here, guys, but they do name these things because of the fact that what they are. You've got nothing better to do. So the guy on the left, the crimper for the RJ45, if you notice, he has 2 holes. He's got one that's big and one that's small. That big one is your RJ45. The small one is your RJ11. To the right of that is a blade. That blade is there for the purposes of you being strip searched in, right up top, right next, there you go.
sorry.
That will get you stopped in an airplane, believe it or not. That'll get you strip searched inside an airplane. That little blade right there, that is actually a knife. Therefore, you cannot take it with you on a plane. You would have to put it into the bag. You could just see my face when I was on the airplane and they were telling me that I was about to kill somebody. I was like, what are you talking about? I don't even have a screwdriver to take that thing off. But besides the point, that blade there is to be able to strip the cables. So you'll be able to clamp this thing and then do like a little circle around the shielded Cat 3 or Cat 5 cable, then pull away and it will take off the actual outer sheath, that blue side of it. But it won't, if you do it correctly, it won't cut any of the cables inside of it. So the RJ45 little tip would go in there and then you just clamp it in after you stuff the actual cables into the back of the female, of the male connector, sorry. You just cramp it on. That's why it's called a crimping tool, because you're just going to crimp the lines on. It then pushes all those gold teeth that we saw. It pushes it onto the line and it bites the line. That's what it does. It actually bites the line with the metal connector when he crimps it on. If it's not terminated correctly, then it won't bite the line and you won't get a full termination of the cable. Questions on the crimper? I think we have also some videos you guys can see of people making cables. So.
I think Mike Myers has a really good one about making cables both types using the punch down and the crimper. I'll see if I can find it.
All right, cool. The next one, so that left one is when you're making a male connector because the tool is a female. You're making a male connector because the tool is a female. You see the female there on the crimping tool? Everyone sees the female. Now the guy on the right, the punch down tool is used to create a female connector, and your tool is a male. What happens here is that this tool, the punch down tool itself, has two sides to it. This side right now that I can see is actually the cutter side. You'll notice that real close to the bottom of the tip, one side is flat and then the other side looks like a little knife, like a little triangle knife, and it has a hole in the middle of it. Can I have control again? Am I moving my mouse, his mouse?
Yeah.
Can you guys see my, all right. All right. So here is the part. This here would be the guide, and that, my friend, is the cutter. Because of the fact right here is the cutter, and this here is a straight tooth. If I take this off, twist it off, flip it around, it becomes now just a guiding tool. Both sides are going to be flat, the side where it cuts and this side. And now I can guide my actual cables into the back of the female connector. He's going to show you a video of this later to be able to explain it better. What we do need to notice is our yellow and our blues. And somewhere around here, it tells us if it is cut or not. Cut side always goes to the outside. The other side goes towards the inside. We need to pay attention because if we leave the cut side in the inside, then it's going to cut the wrong side of the cable when you're making the female tip. Question or doubt on a punch down or a crimping tool?
Just to clarify, a crimper for RJ45 connector, it cuts the RJ45 and RJ11 to make a mill connector. Is that correct?
It grabs the RJ45 connector and you put it in here. Then there's a special way, which we're going to show you a video, that you're supposed to be lining up the cable to the back of that connector and putting each one into its little chamber, because it has a little small chamber inside the actual RJ45 connector. After you slide all the cables in, you're going to put that into the crimper and then crimp it so it closes its mouth and it pushes all those gold teeth that we've talked about, where we're lining up the orange white, the orange, the white green, the blue, the white blue, the green, you know, those colors all straight. So as soon as we get those out and we crimp, it will bite the actual cable inside and close the connection. You got to do it to both ends so you could, what they call, terminate the cable.
Okay. So once it does that, it bites, it crimps, and it bites it. It creates the mill connector, and then you take it to the right of the device, of the punch down, to see.
No, this would be for the wall. The female connector would be the wall. This would be the one that you use to connect to your computer, and then that wall plate. You know how when you go and plug your phone into the wall, that is it's a hole in the wall? Well, that is the tool for that termination, the one that's in the wall. This left one would be the cable that you hold in your hand. This is the one that you use to create the actual termination in the wall. So whenever they give you these test questions and they start asking, oh, this guy's having this problem, and it happens to be the termination in the wall, they're going to go and tell you, okay, are you using a crimper, a punch down tool, a loop back, or this or that? You need to be able to figure out, is it a crimper or is it a punch down tool that I got to use?
Okay.
Depending on which one you're terminating. Is it the one that's going to be going to the computer directly, or is it the one that is in the wall or in the closet? Because the wiring closets use punch downs.
Yes.
The actual cables use the crimping tool.
And the punch down would be on the computer.
The punch down is used on the actual female connector that's on the wall or inside the wall.
It's okay. And all right, so it's not the one that's in the wall is for the female, for used to use the punch down.
Yes. Yeah, I'll show you right now.
I'm trying to follow you on that. Thank you.
All right, there we go. Here's a female connector. This is what it looks like in the wall. So you would punch down onto here. Maybe that's a video right there. Hopefully they can show us a little video. You see how he's guiding it in?
Yeah, I was just saying, don't do that in your hand.
Yeah, don't do what he was doing, but you can see where he's guiding the cable in there. So he uses that to make that actual cable that way. Let me go over here. Forget about it. He's trying to sell something there. But you'll notice that in here, he's got the cut side. You see the yellow where it says cut? You see this here? It says C-U-T, cut. That's because the cut side is here, is this side. So you need to make sure that it faces the outside of this. These cables will be coming in through the inside, the middle of this, and then you just untwist them and you just guide them into that little chamber, that little hole. Then this thing, you come and you just push down and punch down the wire to terminate it. Let me see if he gets to it. Hope he's not making. There he is. He's not making anything easier. This guy's going back and forth. He's trying to show off his little tool. There he is, down here in the bottom.
Okay, so the mail, okay, at first, okay, the mail connecting.
So he's making sure that he basically aligns it. What's great about the female connector is it has its own little sticker on the side of it that tells you exactly how the colors should be. I don't know if you noticed that. Let me get out of this here. Go back over here. It actually has a color code here, and it tells you what color should be what. On top of it, it'll tell you if it's A or B. So depending how your organization is labeling it, if it's creating A or B cables, you need to use either A or B. You'll notice here how green is here. So if this was a B termination, because your company is using B, you need to make sure that white green gets pushed here and green gets pushed here. If this was an A company and was doing wiring by A, then orange, white would be here, then orange, and then white, brown here, and brown. And then obviously the other colors on the other side.
All right.
You see here again. So there's no guessing game here on the female connector. It will tell you exactly where it needs every single wire. You guide it in and you punch it down.
All right, so the punch down device is used to insert in there, and it will tell you which one. It will tell you if it's cut or not. Okay.
Yeah, it'll tell you which way it's cutting. So you need to make sure that the side that's going to be cutting is punching on the outside, and then the other side is sliding on to the other side. So it doesn't cut the inside of the wire. It only cuts the outside here.
That makes more sense. Thank you.
Not a problem.
I found the video real quick if you want it, just for him making a punch down block.
Is it too long? I got another call that's about to start.
No, let's go ahead and finish up. I'll do it later.
All right. Yeah. All right. Sorry about that. Doing two calls at the same time. Let me mute them somehow.
No.
All right. So back to our previous programming. If you could share your screen now. Thank you. So, as you can see here, they're going into untwisting every single one. If you'll notice, though, you want to make sure you don't untwist it beyond this area here. You just really want to twist it to the area that you're getting to close to here. You guide with your hand each and single cable, or you could use the guide side itself. If you want to flip the thing around, you could actually just use the guider itself, as you can see. The third step here is to make sure you use the cutting side to be on the cut side on the outside. you push down. This is just like a hammer that has pressurized. So as soon as you push down, it will go bah! As soon as it releases that firing mechanism, it will attempt, or it should cut it. It may take more than one to cut, but usually one should be sufficient. At the end, you should have clean cables like that, and all of the cables that are in the center. You can then lay down that tip straight down so that it comes inside. A lot of these have a little plastic guide there where you see that little green thing, which is a little cover that they put on top of it. Questions, concerns? Next slide, please. All right, our multimeter and toner probe. Multimeter you're not going to use too much except if you're dealing with the RG6, RJ58, 59 cables. Looking for the 75 ohms or the 50 ohms, depending on the type of cable. That's here nor there. A lot of those cables you're not going to be messing with, but you do need to understand how to use a multimeter itself and what its use. It has voltage capabilities, has ohms capabilities, it has capabilities if the circuit's open or closed. So depending what it is, but the mostly you're going to be using it here for would be obviously for network purposes is ohms. For the computer purposes will be voltage to see what is a volt. No, is it called volts? Yeah, volts. Where? Yeah, amps is the other one. I forget. Volts, amps equals watts. I'm okay. I feel better. How you doing? As for your toner probe itself, the toner probe is used to be able to actually stream onto the network. So this little guy here on this side, if you connect it to the cable, as long as it's not connected to a switch, hear my words, it's gonna happen to you. As long as that cable is not connected to the switch, the toner probe works perfectly. If it's connected to a switch, God only knows why, because I can't figure it out myself. Somehow, some way, it eats the tone. So what I usually do then is I create myself a small little RJ45 cable, Cat6 cable or whatever, and then I peel it so that because a lot of these toners though, they'll have an extra little thing where you could actually choose which wire you want. It has, you see here how this little thing here is? Some of them, how it has this orange and red cable over here on the actual multimeter. Some of them have something like that that sticks out of it that allows you to choose which wire you want. Not all of them. Some of them are expensive like this one, which is the Fluke. And it's smart enough to know that it's connected to an Ethernet and it can still tone through it. But the cheap ones, usually you'll notice they actually have that extra red and black cable so that you can choose which cable you want to send it through. Strongly recommend not using the same colors. So maybe use one brown and one green wire to ensure that it's not the same that's being sent and received so it doesn't eat the sound. What does a toner probe do? It does exactly that. It goes. This guy here on the right is the actual speaker that's able to hear you. Press a button on the other side. So what happens is somebody was nice enough to go and erase the actual label of the port that's on the wall. And since I can't figure out where is this in my closet, they invented the toner probe. The toner probe now will then easily stream so that you can go to the wiring closet and search for it. As soon as you hear the cable that's crying, it's got to be that cable. That's the one that's toning. Oh, you're bringing the little connector? Yeah, there he is. It's hard, but it's there. Questions or concerns on a toner or a multimeter? Next slide, please. I lost access. All right, our loop back plug. The loop back plug is used to actually test an actual physical card, so it's very helpful. If I want to put that to the back of a NIC card, or put it to a switch port, put it to a hub port, put it to any port, it will loop back the signal and simulate like if it's actually connected to something. So I should be able to see the little lights flickering. If I don't see the lights flickering, then obviously there's something wrong with the card. Cable tester. Cable tester here, if you notice, is pretty cute here. It has two parts to it. If you only want to test one cable, you only need the big doohickey. You basically stick the cable to both sides, and then boom, it will then send a signal from 1 all the way up to 8, going in sequential order, so that if the lights light up in order, then obviously it is made as a straight through cable. Now, that little rectangle on the other side, that's the receiver. So now that I tone the cable and I'm all the way on the other side, I can leave this guy here and use the big guy on the other side so that I can be able to test the cable and see if all the lights light up in order. When I get to the other side where the little tester is, if it does not light up in order and it's coming out of sequence, then I know what's wrong with the cable. It'll go maybe 1, 2, 5, 7, 3, 4, 8. Now I know I have a big mess because it didn't go 1, 2, 3, 4, 5, 6, 7, 8. Make sense? That's your cable tester. So each light should light up one by one. Which part doesn't make sense on the cable tester, Will?
No, Mr. Diego, I just, I'm doing my best to keep up on this. I just missed a good amount of information what you mentioned with the difference between cable tester and what does it do. So I'll be honest with you. So that's why I don't understand.
I can go over that with you, Will, in a little bit.
Okay, awesome. Thank you. Thank you.
Okay. All right. Next slide. You said you'll go into that in more detail?
Yeah, I'll go into that with a little bit more detail with him.
Okay. Now, fair warning. Here it says that the crossover cable is as simple as just greens and orange. This is true only in the old crossover cables. All that have to do with gigabit Ethernet and above requires for you to also flip-flop the blues and the browns.
Question, do they classify that as a rollover or is that different?
Rollover cable would be going from 1 through 8, 8 to 1.
Okay.
That is why it's called
just wanted to
rollover,
clarify
because
that.
if you
Thank you.
roll over the cable, it's completely in the backwards. But a full duplex gigabit Ethernet cable for actual crossover uses all 8 wires. So to be able to cross over, you need to cross over all 8 wires.
And this would allow you to
So-
hook up a computer to a computer direct,
A hub to a hub, a computer to a computer.
switch to a switch.
Basically, yeah. Depending on what type of switch, some switches are smart and they can auto sense and do it on their own. But the straight through cable is simply that. It is identically the same. So when I go into that, the cable tester, if I do a straight through cable, it should light up all the lights from 1 through 8. If it is a crossover cable of Cat 5 and below, I should see it going basically in lining up on the other side. It should first light up 3, then it will light up 6, then it's going to light up 1, then it's going to light up 4, then it's going to light up 5. You see what it's doing? Then it's going to light up 2, then it's going to light up 7, then it's going to light up 8. If I'm looking for a crossover cable, that's that way, because the left side would be the module that's sending the signal, and then the right side would be the receiver that's giving me the lights to let me know how it's made. The essence of a crossover cable is to be able to connect two dissimilar devices, a hub with a PC, or a hub, a switch with a switch, or or even a PC with a hub, depending obviously on the if the actual the device is smart enough to be able to connect by itself with another one. Usually PC to PC, you will need a crossover cable.
If you remember the old Xboxes, in order for you to kind of network the Xboxes, they sold a fancy proprietary cable that cost you about $40 for a good cable. All it was a crossover cable.
Need to cue the administrators to somehow send the invite out, which,
Remember that?
you know, I know Wednesday is most likely good, 100% good. So I guess before I cue the administrators.
Any questions?
Back to the previous program. No questions or doubts. Is more of remembering that the 1 and 3, the 2, 6, those interchange with each other.
You're basically, you have one standard on one side of the cable, that 568A, and then on the other side of the cable, you have 568B.
That is true when it comes to the old ones.
Yes.
The new ones requires you to flip-flop on the other side too. But I think for A+, I don't think they really hound you down.
They only worry about
the old one.
The old ones. They don't worry about the, all 8. They only worry about the 4 switching.
Okay. Next slide, please. All right. We are coming towards the end. Isn't that a beautiful thing? So at this point, we should hopefully be able to define a network, give the examples of a actual network, and identify the different devices that are being used within an actual network, identify the types of network cables and or connectors, and lastly, recognize the actual most common tools. As I stated, a computer network is a group of computer systems and other hardwares and devices that are linked together to be able to facilitate a type of communication or exchange of data amongst the network links. We need to understand that the network links are computer cables or connectors, and we have learned that these networks can be different types of networks, be that they're, you have your PANs, you have your LANs, you have your WANs, your wireless LANs, your MANs, your mesh topologies, you have your ring, you have your bus, you have your star, and you have your hybrid. All these encompasses the different types of logical versus we also have physical networks. We need to be able to decipher between the two of them. There's no questions for me. This is as far as I play. I pass it back off to Kelly.